From building the highest bridge deck in the world, 625 meters above a river, to a $27 billion pipeline deep in the Arctic permafrost, we will cover some of the world's most isolated megaprojects. We will tell the story of a walking research station in Antarctica and the story of the world's most faraway islands. These aren't just megaprojects. These are human creations that exist against all odds. Don't miss out as we uncover how Canada built a dam hundreds of kilometers away from any human settlement and why a capital meant for millions stays deserted after a decade. In the mid-1960s, British Columbia decided to build the largest earth-filled dam in North America in a stretch of the Rocky Mountains where there was, in practical terms, nothing. No town nearby, no road capable of handling industrial freight, no workforce within reasonable reach, just the Columbia River cutting through mountain wilderness and the hydro potential that represented. Before a single cubic meter of earth could be moved for Mica Dam itself, BC Hydro had to build the means to get there. A 130-kilometer access road was carved through the Rocky Mountain terrain from Revelstoke to the dam site, an undertaking that in other contexts would have been a significant infrastructure project on its own. The road had to be engineered to handle the continuous heavy traffic of a major construction operation through a mountain environment that included steep grades, river crossings, avalanche zones, and winters that tested the limits of what equipment could operate through. The workforce that built Mica lived on site for the duration. A construction camp was established near the dam that housed thousands of workers through multiple Canadian winters, with temperatures dropping well below -30 degrees Celsius for extended periods. Supply convoys kept the camp stocked with everything from concrete aggregate to food, running that 130-kilometer road through conditions that regularly made it dangerous. Workers rotated on schedules designed around the psychological reality of extended isolation in a mountain camp with no nearby town, no casual exit, and months of winter darkness. The dam itself is a massive earth and rock-fill structure, 244 meters high and nearly a kilometer wide at its crest. Building it required moving and placing tens of millions of cubic meters of carefully graded fill material in a precise sequence with different zones of material type, creating the internal structure that allows an earth dam to hold back the volume of water Mica was designed to contain. The reservoir it created, Kinbasket Lake, stretches over 200 kilometers up the Columbia River Valley, one of the largest reservoirs in Canada. The Columbia River's behavior dictated the construction sequence in the same way rivers always do on dam projects, managing river diversion, controlling flow through the partially complete structure during high water periods, and timing the closure of the dam to coincide with manageable river conditions required years of planning and precise execution in a mountain environment where the river does not behave predictably. Mica Dam was completed in 1973 after roughly 8 years of construction. Its generating capacity has been expanded over the decades since and now stands at 1,805 megawatts. It remains one of the largest hydroelectric facilities in British Columbia and a cornerstone of the provincial grid. The access road built to construct it eventually became the route that opened the Columbia River Valley to permanent settlement further north, a consequence of the project that its planners anticipated and that transformed the region in ways that outlasted the construction itself. The Yucatan Peninsula looks accessible on a map. It has cities, coastline, and tourist infrastructure, but strip away Cancun and the resort corridor, and what remains is a vast limestone jungle, the second largest tropical forest in the Americas, with almost no heavy infrastructure connecting its interior, towns separated by hours of dirt road, communities that have existed largely outside the modern economy for generations, and beneath it all, a hidden world of cenotes, caves, and underground water systems that nobody had fully mapped. And this is where Mexico decided to build one of the biggest rail systems in the world. Tren Maya had to be built despite everything that the region threw back. While this wasn't remote in the way a Siberian tundra is remote, it was remote in a more complicated way. Inhabited, ancient, and fundamentally hostile to the kind of industrial-scale construction that was about to arrive. Getting equipment into the jungle interior meant building access routes before the actual project could begin. The Yucatan has no major rivers suitable for freight. Roads capable of handling construction loads either didn't exist or had to be carved from scratch. In the early phases, machinery was moving through terrain that actively resisted movement. Dense canopy, soft limestone ground that shifted unpredictably, and a wet season that turned access routes into mud within hours. Then the ground opened up. As crews pushed deeper into the jungle, they began hitting voids beneath the surface. Caverns, cenotes, underground passages that gave no warning from above. In some stretches near the Mayan archaeological zone around Campeche, drilling equipment broke through into spaces large enough to drive a truck through. Entire sections of the route had to be redesigned. In the most unstable areas, the track was elevated on raised structures above the ground rather than laid through it. The only way to guarantee it wouldn't eventually sink into what lay below. Keeping thousands of workers operational in those conditions was its own battle. Extreme humidity, venomous wildlife, heat peaking well above 40 degrees Celsius in the dry season. And then the jungle started giving up its secrets. As construction cut through the interior, it kept finding things. Thousands of Mayan artifacts surfaced along the route. Structures, ceramics, burial sites that had sat undisturbed for centuries. Work halted repeatedly to allow excavations. By the time the project was complete, over 30,000 archaeological pieces had been recovered, turning parts of the build into an accidental dig site at industrial scale. The opposition never quieted. Scientists, indigenous communities, and conservation groups argued that a railway cutting through the jungle would fragment critical ecosystems, threaten the underground water table, and cause damage that couldn't be undone. Legal injunctions ran parallel to construction for years. The finished railway stretches 1,554 kilometers, making it the longest passenger line in Mexico and one of the longest in Latin America. It connects 5 states, passes through or near dozens of Mayan sites, and links communities that previously had no rail connection to the rest of the country. At peak construction, over 17,000 workers were active across simultaneous build fronts. The total cost exceeded $20 billion. Whether it was worth it depends entirely on who you ask. For the communities it connects, many of them poor and economically isolated for generations, it's a lifeline. For the ecologists and archaeologists who watched it go up, it's a wound cut through something irreplaceable. The jungle is already growing back around the tracks in places. But next up, we have an even more extreme railway megaproject in China, one that was built at an altitude where the human body may struggle to function properly. The Qinghai-Tibet Railway is built at 5,072 meters above sea level, making it the highest railway ever built, and it runs through some of the world's harshest terrain for over 960 kilometers. The railway connects Xining in Qinghai Province to Lhasa, the capital of Tibet, crossing the Tibetan Plateau, a landmass so high and so vast, it's known as the roof of the world. Before this line existed, reaching Lhasa by land meant days of grueling road travel through terrain that regularly closed in winter. Tibet was effectively cut off from the rest of China in any practical modern sense. The railway was built to change that permanently. The distance is 1,956 kilometers in total. The section from Golmud to Lhasa, the stretch that broke every record, took 5 years to complete and required solutions that had never been attempted at this scale anywhere on Earth. Half the route runs over permafrost, not frozen ground that thaws in spring, but deep, ancient permafrost that had been stable for thousands of years until construction equipment arrived and began generating heat. Permafrost melts unevenly. It subsides in patches. A railway track laid directly onto it would warp, buckle, and eventually become unusable within years. Chinese engineers solved this by essentially refrigerating the ground beneath the tracks. Thermosiphon devices were driven into the earth along the most vulnerable stretches, passively drawing heat out of the ground and keeping the permafrost frozen even as the climate around it warmed. It was an engineering approach borrowed from pipeline construction in Alaska and Canada, scaled up to a degree nobody had attempted before. Over 160 bridges and tunnels were built along the route. The Fenghuoshan Tunnel, at 4,905 meters above sea level, was the highest railway tunnel in the world at the time of construction. Workers inside it were operating at altitudes where oxygen levels are roughly 60% of what they are at sea level. China built oxygen-enriched work camps along the line, pumping pressurized air into sleeping quarters and work tents to keep crews functional. Mobile medical units followed construction teams across the plateau. Over 100,000 workers were deployed at peak. The project recorded remarkably few altitude-related fatalities given the conditions, a result of the medical infrastructure built specifically around the workforce. The trains themselves had to be redesigned. Standard rolling stock can't function at that altitude. The carriages used on the Qinghai-Tibet line are pressurized like aircraft cabins, with individual oxygen supplies at each seat. The locomotives were modified to operate in thin air, where combustion and cooling systems behave differently than at sea level. The line opened in 2006, on schedule, after 5 years of construction. It cost approximately $4.2 billion. It carries passengers and freight across a plateau that was, for most of human history, considered simply impassable. The controversy around it has never fully settled. Tibet's political status means the railway carries weight beyond engineering. Critics argue it accelerated Han Chinese migration into the region and deepened Beijing's grip on a territory with a contested history. Supporters point to the economic development it unlocked and the hundreds of thousands of Tibetans who now have direct rail access to the rest of the country. Both things are true, and neither cancels the other out. What isn't contested is what was built: a railway across the roof of the world, through frozen ground, at altitudes that kill, completed on time, and still running today. From these extraordinary rail projects, we move to some of the most extraordinary dams in most isolated locations. In 2011, Brazil broke ground on a dam in the middle of the Amazon. What followed was 10 years of jungle, floods, and one of the most bitterly contested construction projects on Earth. Belo Monte is the third largest hydroelectric dam ever built. It sits deep in the Brazilian Amazon on the Xingu River, roughly 500 kilometers from the nearest major city. Building it meant moving more earth than was excavated for the Panama Canal, in a jungle that receives over 2 meters of rainfall per year, and in a region with no existing heavy infrastructure. Getting materials to the site required building that infrastructure first. A dedicated port was constructed on the Xingu River to receive heavy equipment shipped in by barge. Roads were cut through the jungle to connect the construction zone to supply lines. At peak, the site was operating like a small city, housing over 30,000 workers with their own hospitals, schools, and supply chains, running continuously to keep construction moving. The Xingu is not a simple river to engineer around. Its flow varies enormously between wet and dry seasons, which dictated the entire construction sequence. Work had to be staged around the river's behavior, with different sections of the dam built during windows when water levels and currents allowed it. Cofferdams, temporary structures used to hold back water while permanent works are built behind them, had to be erected and dismantled in sync with seasonal cycles. Missing a window meant waiting an entire year. The scale of what was built is staggering. The Belo Monte complex includes 2 powerhouses, dozens of kilometers of canals, multiple dikes, and a main dam structure that required moving 240 million cubic meters of earth and rock during construction. The reservoir created by the project covers nearly 500 square kilometers. The installed generating capacity is 11,233 megawatts, enough to power the equivalent of 60 million Brazilian homes at full output. Full output, however, is the problem. The Xingu's flow drops dramatically in the dry season, and Belo Monte was designed without large water storage reservoirs, meaning its actual average output runs well below its theoretical maximum. Critics called this a fundamental design flaw built into the project from the beginning. The dam's operators and the Brazilian government argued the numbers still justified the investment when integrated across the full year. While it was billed as a net positive for the country, the construction began with a significant human cost. Approximately 40,000 people were displaced by the project, many of them indigenous communities whose lives along the Xingu had remained largely unchanged for centuries. The flooding altered fish migration patterns the river communities depended on. Environmental groups, indigenous rights organizations, and figures including the filmmaker James Cameron flew to the region to oppose the project publicly. Legal battles ran for years. Construction continued regardless. Belo Monte was completed in stages between 2016 and 2019. Its final cost reached approximately $18.5 billion, nearly double the original estimate. It now supplies a significant share of Brazil's national grid, a grid that was experiencing serious shortages and blackouts in the years before the dam came online. Whether the Amazon paid too high a price for that power is a question Brazil is still working through. The river keeps moving. The dam isn't going anywhere. Laos is one of the most landlocked and least industrialized countries in Southeast Asia. It has no coastline, limited road infrastructure across most of its interior, and a national grid that for most of its population has historically meant unreliable power, or none at all. Nam Theun 2 was built to change that, not by powering Laos, but by selling electricity to Thailand and using the revenue to fund the country's development from the outside in. The dam sits on the Nam Theun River on the Nakai Plateau, a remote highland region in central Laos, roughly 250 kilometers east of the capital Vientiane. Before construction began, the plateau was accessible by a single unpaved road that became impassable in the wet season. There was no heavy freight route, no port, no existing industrial infrastructure of any kind. Everything the project needed had to be brought in, and in many cases the means of bringing it in had to be built first. A new road was constructed from the Thai border to the project site, capable of handling the convoys of heavy equipment and materials that would sustain years of continuous construction. A temporary airstrip was built near the site for personnel and priority freight. The construction workforce at peak reached around 7,000 people, housed in a purpose-built camp on the plateau that operated its own water treatment, medical facilities, and power supply independently of anything the surrounding region could provide. The Nakai Plateau sits at the edge of one of the last intact lowland forest ecosystems in Southeast Asia. The reservoir created by the dam flooded approximately 450 square kilometers of that forest, displacing around 6,200 villagers from communities that had lived on the plateau for generations. The resettlement program that accompanied the project was among the most extensively documented in the history of large dam construction, designed under World Bank oversight with commitments to land replacement, livelihood support, and long-term monitoring. Whether those commitments were fully honored remains a contested point between the project's developers and the communities affected. The environmental conditions during construction were brutal in the way that jungle environments always are. Humidity, heat, monsoon rains that turned access routes into rivers, and a wet season that effectively shut down certain phases of work for months at a time. The dam itself, a concrete-faced rock-fill structure, required continuous supply of aggregate and fill material from quarries established near the site, with haulage roads maintained through conditions that degraded them almost as fast as they could be repaired. Nam Theun 2 began generating power in 2010. Its installed capacity is 1,070 megawatts, with the vast majority of output exported directly to Thailand under a long-term power purchase agreement. The revenue flows to the Lao government and has funded infrastructure, education, and health programs across the country. It became a reference case in international development circles for the model of using natural resource exploitation to finance national development, and a cautionary example for those who argue the communities displaced by such projects rarely see proportionate benefit. The dam generates power continuously. The plateau it flooded does not come back. The Yamal Peninsula sits at the top of Russia, where the Arctic Ocean meets Siberia. In winter, temperatures drop to -50 degrees Celsius. The ground is frozen solid year-round. There are no roads in or out. There is no port. There is, or was, almost nothing there at all. Russia built one of the largest liquefied natural gas plants on Earth on it anyway. The Yamal LNG project was designed to extract natural gas from fields beneath the peninsula, cool it to -162 degrees Celsius to liquefy it, and ship it out through Arctic waters to markets in Europe and Asia. The scale of what that required, in a place that extreme, defines what makes Yamal different from almost every other energy project ever attempted. Everything had to be brought in by sea, and only during the narrow Arctic summer window when ice conditions allowed. A dedicated port was built from scratch at Sabeta, on the eastern shore of the peninsula, dredged out of shallow Arctic waters and constructed to handle the kind of cargo volumes that would supply a continuous industrial operation in one of the most inaccessible places on the planet. In winter, when the port froze over, specially built ice-breaking LNG tankers kept the supply lines moving, vessels designed specifically for this project that can operate independently in ice over 2 meters thick. The workforce at peak numbered around 30,000 people, living in an Arctic industrial camp that functioned as a self-contained city. Flights were the only way in or out for most of the year. Workers rotated on schedules designed around the psychological and physical limits of sustained Arctic exposure, with rest periods mandatory and medical infrastructure built directly into the camp, in temperatures where exposed skin freezes in minutes. Outdoor construction work required specially engineered equipment, heated suits, and strict time limits on surface exposure. The permafrost presented the same fundamental problem it creates for every structure in the Arctic. Buildings and industrial equipment placed on frozen ground generate heat that melts the permafrost beneath them, causing subsidence and structural failure. Every structure at Yamal was built on thermally insulated piles driven deep into the ground, with air gaps beneath buildings to prevent heat transfer. The same principle applied to pipelines, processing equipment, and the port infrastructure. The 3 LNG processing trains at Yamal, the core of the plant, were not built on site. They were constructed in modules in shipyards in China, South Korea, and Europe, then transported on heavy lift vessels through Arctic waters and assembled at Sabeta. Moving prefabricated industrial modules the size of apartment blocks across thousands of kilometers of ocean, through ice, and landing them precisely onto prepared foundations in an Arctic port was a logistical sequence that took years of planning and had no precedent at this scale. Yamal LNG produced its first cargo in 2017. By 2019, all 3 processing trains were operational. The total investment reached approximately $27 billion. It now supplies LNG to markets across Europe and Asia year-round, with the ice-breaking tanker fleet keeping shipments moving even through the depths of the Arctic winter. The project sits inside one of the most geopolitically sensitive energy corridors in the world, and the sanctions imposed on Russia following the invasion of Ukraine in 2022 have complicated its international partnerships significantly. The technology and financing that made Yamal possible came partly from Western partners who have since withdrawn. A planned expansion, Arctic LNG-2, has stalled as a result. What was built, however, keeps running. The Arctic doesn't pause for politics. Next up, we have 2 of China's craziest megabridges, built hundreds of kilometers away from any civilization. China opens a new bridge somewhere almost every week. This one is different. The Huajiang Grand Canyon Bridge spans a gorge in Guizhou province so deep that clouds form below the deck. When it opened in 2024, it became the highest bridge in the world, with a deck sitting 625 meters above the Beipan River. To put that in perspective, you could stack the Eiffel Tower on top of itself 3 times and still not reach the roadway. Guizhou is one of China's poorest and most mountainous provinces. The terrain is a maze of karst peaks, sudden gorges, and valleys that made building any kind of modern transport network across the region extraordinarily difficult. Communities on opposite sides of these canyons were separated not by distance on a map, but by hours of winding mountain road. The Huajiang Bridge was built to collapse that separation permanently. The gorge itself dictated everything. At 625 meters deep and over a kilometer wide at the crossing point, there was no conventional way to string a bridge across it. The foundations had to be anchored into near-vertical canyon walls on both sides, with construction teams working on cliff faces using equipment suspended over drops that left no margin for error. Drilling into the rock to seat the anchor points required precision at heights where standard construction methods simply don't apply. The main span stretches 1,420 meters between towers. Building the towers themselves meant working at different elevations simultaneously, with crews on the canyon rim above and others operating hundreds of meters below on platforms fixed to the cliff face. materials and equipment moved by cable systems strung across the gorge before the bridge structure existed to carry anything. Getting a single load of concrete to the right position could take the better part of a working day. Wind was a constant variable. At that elevation, in an open canyon of that scale, gusts are unpredictable and strong enough to affect the movement of heavy loads on cables. Construction schedules were built around weather windows, and crews learned to read conditions in a gorge that generates its own microclimate. The bridge carries a 6-lane expressway and cuts the travel time between communities on either side of the canyon from around 4 hours to approximately 3 minutes. It is part of a broader infrastructure push across Guizhou that has seen dozens of major bridges built over the past 2 decades, transforming a province that was once considered too difficult to connect into one of the most bridged regions on Earth. Guizhou now hosts more than half of the world's highest bridges. The Huajiang is the tallest of them all, and by the time another country attempts something at this scale, China will likely have built several more. Building a bridge across open seas is hard. Building one across one of the busiest shipping lanes in the world, in Typhoon territory, with 3 different governments involved, is something else entirely. The Hong Kong-Zhuhai-Macau Bridge stretches 55 kilometers across the Pearl River Delta, making it the longest sea crossing ever built. It connects 3 of the most economically significant cities in southern China, a region that collectively generates more GDP than many mid-sized countries. Before it existed, the road journey between Hong Kong and Zhuhai took 3 to 4 hours. The bridge does it in 30 minutes. The Pearl River Delta is not open water. It is one of the most congested maritime corridors on Earth, with thousands of cargo ships, tankers, and ferries moving through it every day. Running a bridge across it would have blocked shipping lanes that the regional economy depends on. The solution was to take the bridge underwater for a section in the middle, dropping into a 6.7-kilometer undersea tunnel that allows vessels to pass over the top while traffic continues below. The transition points between bridge and tunnel required the construction of 2 artificial islands, each roughly the size of several city blocks, built from scratch in open water to house the tunnel portals. Those islands took about 3 years to build. Steel cylinders, each weighing hundreds of tons, were driven into the seabed and filled with sand and concrete to form the foundations. The precision required to position them correctly in tidal currents and shipping traffic, without disrupting either, pushed construction teams to the edge of what marine engineering had done before. The main bridge structure had to be built with typhoon loads factored into every joint and cable. The Pearl River Delta sits in an active typhoon corridor, and the bridge was designed to withstand winds that would shut down most infrastructure in the region. Seismic activity added another layer, with the structure engineered to flex rather than resist during ground movement. In total, over 400,000 tons of steel went into the crossing, enough to build 60 Eiffel Towers. The project employed around 14,000 workers at peak, many of them living on accommodation vessels anchored near the work site. The total cost reached approximately $18.8 billion. It opened in 2018, after 9 years of construction. The politics of who can actually use it added a layer of complexity the engineering couldn't solve. Due to different vehicle registration and permit systems across Hong Kong, Macau, and mainland China, access to the bridge is restricted. Most travelers cross via shuttle buses rather than private vehicles, which limited the traffic volumes that were originally projected. The bridge carries far fewer vehicles per day than its capacity allows, a gap between engineering ambition and administrative reality that still draws criticism. What it achieved structurally remains largely without precedent. A 55-kilometer crossing, part bridge, part tunnel, with artificial islands built in open water across one of the most active shipping lanes on Earth. India has been building a railway through the Himalayas for over 2 decades. It is not finished yet. The Udhampur-Srinagar-Baramulla rail link was launched in 1997 with the goal of connecting the Kashmir Valley to the Indian rail network for the first time. Kashmir sits in the northwestern Himalayas, bordered by Pakistan, China, and some of the most geologically unstable terrain on Earth. Before this project, the valley was accessible by road through mountain passes that closed for months every winter, leaving it effectively cut off from the rest of the country on a seasonal basis. The railway was supposed to take a few years. The geology had other plans. The central section of the line between Katra and Banihal passes through the Greater Himalayas, a stretch of mountain terrain so fractured, so prone to landslides, avalanches, and seismic movement that construction teams spent years simply trying to understand what they were building into before they could begin. Bore surveys revealed rock formations that changed composition within meters, with hard granite giving way to soft shale unpredictably. Tunnels that appeared straightforward on paper collapsed during drilling. Methods had to be abandoned and redesigned repeatedly. The numbers that came out of this section are genuinely difficult to process. The Banihal-Kazagun Tunnel alone stretches 11.2 kilometers. The Pir Panjal Tunnel runs 11.2 kilometers through a mountain range that experiences regular seismic activity. But neither of those is the defining structure of the project. That distinction belongs to the Chenab Bridge, which when completed became the highest railway bridge in the world, with its arch rising 359 meters above the Chenab River, taller than the Eiffel Tower. Building the Chenab Bridge arch required constructing it from both sides of a deep river gorge simultaneously, with the two halves meeting in the middle. The arch had to be supported by a cable stay system during construction, with temporary stays holding the structure in position until the two sides connected and the arch became self-supporting. Wind speeds in the gorge regularly exceeded the limits for safe crane operation, shutting work down for days at a time. The arch is designed to withstand winds of 266 kilometers per hour and a full seismic event. Workers on this project weren't rotating through a purpose-built camp near a city. They were living in temporary settlements inside one of the world's most active conflict zones, in terrain that avalanched without warning, at altitudes where winters are brutal and supply lines thin. The project has seen extended stoppages, security incidents, and cost revisions that have taken the total bill from an original estimate of around $2 billion to over $35 billion across the full line. Sections of the railway have opened progressively. The full connection to Srinagar is expected to bring a rail link to a valley that has waited nearly 30 years for one. When the final spike goes in, it will be one of the most expensive kilometers of railway ever built, through terrain that fought back at every stage. The Atacama Desert in northern Chile is one of the driest places on Earth. In some parts of it, there is no recorded rainfall in human history. The air is so thin and so dry that it is almost entirely free of water vapor, which makes it useless for agriculture, hostile to human life, and perfect for looking at the universe. The Atacama Large Millimeter Array, ALMA, sits at 5,050 meters above sea level on the Chajnantor Plateau. It is the most complex ground-based telescope ever built, an array of 66 high-precision antennas that function together as a single instrument capable of observing the cold universe, the clouds of gas and dust where stars and planets form, with a clarity no telescope before it could match. Getting those 66 antennas to the plateau required building a road capable of handling vehicles carrying loads up to 115 tons, up a mountain, to an altitude where construction workers needed supplemental oxygen just to function. The antennas themselves, each one a precisely engineered dish weighing over 100 tons, were transported individually up that road on custom-built antenna transporters, vehicles with 28 wheels and their own active suspension systems designed to keep the dish level to within fractions of a millimeter, regardless of the road surface beneath them. The construction workforce operated on strict rotation cycles because sustained exposure at that altitude causes lasting physiological damage. Workers would spend a limited number of days at the high site, then descend to a support facility at 2,900 meters to recover before returning. Even with those protocols, altitude sickness was a constant presence. Headaches, fatigue, and impaired coordination were routine. The more serious risk, pulmonary edema, the flooding of the lungs with fluid, was a medical emergency that the site's health team was permanently prepared for. The antennas had to be positioned and repositioned across the plateau in different configurations depending on what astronomers wanted to observe, which is why the transporters were built to move them rather than fix them permanently. coordinating the movement of 100-ton precision instruments across high-altitude terrain without damaging equipment that cost tens of millions of dollars per unit was an operational challenge that continued long after construction was complete. The electronics at the heart of ALMA operate at temperatures close to absolute zero, cooled by cryogenic systems that have to function reliably in an environment that is already brutally cold by any human standard. The signal processing required to combine data from 66 separate antennas into a single coherent image is handled by a correlator. At the time of its construction, the most powerful scientific computer ever built for a single instrument. ALMA took over a decade to construct and reached full operation in 2013. The total cost was around $1.4 billion, shared across a partnership of North American, European, and East Asian institutions. Since opening, it has produced observations that have reshaped understanding of planetary formation, galaxy evolution, and the molecular chemistry of deep space. In 2019, the data it contributed helped produce the first direct image of a black hole's event horizon. At 5,050 meters, in a desert that doesn't rain, the clearest window humanity has into the cold universe sits pointed at the sky. Norway has a geography problem. Its western coastline is one of the most fragmented on Earth, cut through by fjords that make direct road travel between coastal communities functionally impossible without ferries. The ferry crossings work, but they are slow, weather-dependent, and a bottleneck for a modern economy that needs reliable, year-round connections. The Rogfast Tunnel is Norway's answer to one of those crossings. When complete, it will be the longest and deepest road tunnel in the world, running 26.7 kilometers beneath the Boknafjord, reaching a depth of 392 meters below sea level at its lowest point. It will replace a ferry crossing that currently takes about 25 minutes, but requires travelers to stop, board, wait, and disembark, adding time and unpredictability to every journey. Drilling a tunnel 26.7 kilometers through subsea rock at that depth is not a straightforward engineering exercise. The rock beneath the Boknafjord is hard but fractured in places, with zones of weakness that pressurized water exploits. At 392 meters below sea level, the water pressure against the tunnel walls is immense. Breakthrough points, where the drill breaks into a weakness in the rock, can result in water ingress at volumes that halt construction entirely until grouting operations seal the fracture. Managing water has been one of the dominant technical challenges throughout the build. The tunnel is being bored by tunnel boring machines from multiple faces simultaneously, with crews working from both ends and from an intermediate access point to accelerate progress. The spoil, the rock excavated from the tunnel, has to be transported out continuously, while fresh concrete lining segments and construction equipment move in the opposite direction, a logistical choreography that runs around the clock. The tunnel descends steeply from both portals to reach its deepest point beneath the fjord, which creates a long downhill gradient for vehicles entering from either side. Managing ventilation in a tunnel that long and that deep, ensuring that vehicle exhaust and emergency smoke can be cleared effectively, required a ventilation system of a scale that pushes the boundaries of what has been built into a road tunnel before. Emergency laybys, cross passages, and evacuation routes had to be engineered into the tunnel at regular intervals throughout its length. Construction began in 2018, and the project has faced delays and cost increases that have pushed the opening date and the budget beyond original projections. The current cost estimate sits at approximately 43 billion Norwegian krone, roughly $4 billion. When it opens, it will form part of the E39 Coastal Highway project, Norway's broader ambition to create a continuous ferry-free road connection along its entire western coast. A project so large and so expensive, it is sometimes described as Norway's most ambitious infrastructure undertaking ever. The Boknafjord crossing is one piece of that. When vehicles drive through Rogfast, they will be traveling deeper below sea level than almost any road on Earth, through a tunnel that took the better part of a decade to bore, beneath a fjord that gave no ground easily. The Alps have divided Europe since before Europe was a concept. Every trade route, every military campaign, every attempt to move goods between northern and southern Europe has had to reckon with them. The Gotthard Pass in central Switzerland has been one of the primary crossing points for centuries. In winter, it closes. At all times, it is slow. The Gotthard Base Tunnel was built to go through the Alps rather than over them. At 57.1 kilometers, it is the longest railway tunnel in the world. It runs in a straight line beneath the Swiss Alps at a near-flat gradient, connecting Erstfeld in the north to Bodio in the south, cutting the rail journey between Zurich and Milan by nearly an hour, and allowing freight trains that previously had to crawl over mountain passes to move at full speed through the heart of the continent. The project took 17 years to build and required excavating approximately 28 million tons of rock. The tunneling was done by a combination of tunnel boring machines and conventional drill and blast methods, with different techniques applied depending on the rock conditions encountered at different depths. The geology beneath the Alps is not uniform. Crews moved through granite, through gneiss, through unexpected zones of fractured rock and water under pressure, each transition requiring a reassessment of the drilling approach and pace. At its deepest point, the tunnel sits 2,300 meters beneath the mountain surface above it. The rock at that depth is under enormous pressure and generates significant heat. Temperatures inside the unventilated tunnel during construction reached 46 degrees Celsius. Workers were operating in conditions that required continuous cooling systems just to make the environment survivable, let alone productive. 4 main access tunnels were drilled from the surface to allow construction to proceed from multiple intermediate points simultaneously, rather than purely from the 2 ends. This was essential to completing the project within any realistic time frame. Even with those access points, coordinating construction across multiple headings, managing the spoil removal, the concrete lining installation, and the installation of railway systems while tunneling was still ongoing in adjacent sections, was a project management challenge on a scale that had no direct precedent. Around 2,600 workers were on site at peak, drawn from across Europe. The project recorded 9 fatalities over its construction period, a number that project managers considered a marker of the safety systems in place given the scale and duration of the work. The total cost reached approximately 12.2 billion Swiss francs, making it one of the most expensive infrastructure projects in European history. The tunnel opened in June 2016 and entered full commercial operation shortly after. It now carries both high-speed passenger trains and heavy freight, moving goods between northern and southern Europe through the mountain rather than around or over it. The Alpine crossing that shaped trade routes for centuries now takes trains 17 minutes to complete at 200 kilometers per hour. The Massif Central Plateau in southern France drops without warning into the Tarn River Valley, a gorge several hundred meters deep that cuts directly across the main route between Paris and the Mediterranean. For decades, every vehicle making that journey had to descend into the valley and climb back out, or queue through the town of Millau below, which turned summer holiday traffic into a gridlock that became a national frustration. France decided the solution was to go over it entirely. The Millau Viaduct, completed in 2004, is the tallest bridge in the world. Its highest mast reaches 343 meters, taller than the Eiffel Tower. The roadway itself sits 270 meters above the valley floor at its highest point. It carries the A75 motorway across a 2.46-kilometer span on 7 concrete piers, each one sunk into valley ground and rising to heights that put the deck above the clouds on overcast mornings. The engineering problem wasn't simply height, it was achieving that height while maintaining the structural precision a motorway demands. The deck had to be level, smooth, and geometrically consistent across its full length, despite being assembled in sections pushed out from both sides of the valley on temporary supports. The technique used was incremental launching, where sections of the deck were built on the valley rim and then hydraulically pushed forward over the piers in stages. At certain points during construction, sections of deck were cantilevering over 600 meters into open air with nothing beneath them but valley floor. Wind in the Tarn Gorge is constant and directional, channeled by the valley walls into forces that the bridge had to be designed to absorb rather than resist. The deck incorporates a slight curvature in both the horizontal and vertical plane, which improves aerodynamic stability and prevents the resonance effects that have caused structural failures in long-span bridges elsewhere. The 7 piers are not perfectly vertical either. Each one leans very slightly inward at the top to account for the curvature of the earth across the bridge's length, a detail that is invisible to anyone crossing it, but essential to the geometry holding together. Construction employed around 2,000 workers over 3 years. The project finished on schedule and within its €394 million budget, which for a structure of this scale and ambition is almost as remarkable as the bridge itself. It opened in December 2004 and has since become one of the most visited structures in France, drawing people who come not to cross it, but simply to look at it. Every morning when low cloud fills the Tarn Valley, drivers on the A75 cross above it on a deck that appears to float free of the ground entirely. The valley that stopped traffic for generations now takes less than a minute to cross at motorway speed. The Mojave Desert receives more sunlight per square meter than almost anywhere in the continental United States. It also has no water, no shade, summer temperatures that exceed 50 degrees Celsius, and until recently, very little reason for anyone to be there in large numbers. Ivanpah changed that. The Ivanpah Solar electric generating system sits on 14 square kilometers of desert in San Bernardino County, California, near the Nevada border. It is not a conventional solar farm. Rather than photovoltaic panels converting sunlight directly into electricity, Ivanpah uses a different approach entirely. Around 350,000 computer-controlled mirrors, called heliostats, are arranged across the desert floor in concentric arcs around 3 central towers. Each mirror tracks the sun independently throughout the day, reflecting concentrated sunlight onto boilers at the top of the towers. The heat generated produces steam, which drives turbines to generate electricity. At full output, the plant produces 392 megawatts, enough to power approximately 140,000 homes. Building 350,000 individual mirrors across 14 square kilometers of desert, each one requiring its own foundation, motor system, and connection to a central control network, was a construction and logistics challenge that dwarfed most comparable energy projects. Over 100,000 tons of steel went into the heliostat structures alone. The 3 towers, each rising over 130 meters from the desert floor, had to be constructed in an environment where summer working conditions pushed crews to their physical limits, and where the concentration of reflected sunlight created hazard zones around the towers that required strict operational protocols during construction. Water, essential for the steam cycle and for cleaning the mirrors, had to be managed carefully in a desert with no natural water source nearby. A water supply infrastructure was built as part of the project, with conservation systems designed to minimize consumption in a region where water is a resource with its own political and environmental weight. The project faced sustained opposition from environmental groups, which created a specific tension. A solar plant built to reduce carbon emissions was simultaneously destroying desert tortoise habitat and disrupting a fragile ecosystem that had taken centuries to establish. Thousands of tortoises were relocated during construction. Critics argued the relocation programs were inadequate. The desert doesn't recover from industrial-scale ground disturbance quickly, and the footprint of 14 square kilometers is not a small imposition on an ecosystem that functions on subtle balances. Since opening in 2013 and 2014, Ivanpah has consistently underperformed its projected output, partly because the Mojave's actual cloud cover exceeded the models used during planning, and partly because the technology, while functional, proved less efficient in real-world desert conditions than its developers had projected. The plant has required natural gas supplements to maintain steam pressure on lower sunlight days, which drew pointed criticism given that it was built as a zero-emission facility. The investment totaled approximately $2.2 billion. It remains the largest concentrated solar thermal plant in the world, a record it has held since opening, and a demonstration that the technology works at scale, even if the economics have proven more complicated than the original projections suggested. There is nothing at Dogger Bank. That is precisely the point. Dogger Bank is a submerged sandbank in the North Sea, sitting between 125 and 290 kilometers off the northeast coast of England. It is shallow enough by North Sea standards, between 18 and 63 meters deep, but it is open ocean, exposed to North Sea weather, with no land nearby, no shelter, and conditions that shut down marine operations for significant portions of the year. When the decision was made to build the world's largest offshore wind farm there, the nearest question wasn't how, it was why anyone would attempt it at all. The answer was wind. Dogger Bank sits in one of the most consistently windy stretches of ocean in the world, where prevailing Atlantic weather systems produce wind speeds and consistency that onshore sites and nearshore installations can't match. The further offshore, the stronger and steadier the wind. Dogger Bank is far enough offshore that its turbines operate at capacity factors that make the economics, despite the staggering logistical difficulty, work. The wind farm is being built in 3 phases, designated A, B, and C, each one a separately consented and financed project. Combined, they will install 277 turbines across an area of approximately 516 square kilometers of open ocean. Each turbine stands on a monopile foundation driven into the seabed, with the nacelle sitting over 150 meters above the water surface. The turbines being installed are among the largest ever built, with rotor diameters exceeding 260 meters. A single rotation of one blade generates enough electricity to power a home for 2 days. Installing foundations in open ocean, 130 kilometers from shore, required a fleet of specialized vessels that don't exist in large numbers anywhere in the world. Heavy lift vessels, installation ships, crew transfer vessels, and floating accommodation units had to be coordinated in a logistics chain that ran continuously during weather windows, with any delay cascading through a schedule that had no buffer to absorb lost days easily. The monopile foundations, each weighing thousands of tons, were manufactured on shore, transported by sea, and driven into the seabed by hydraulic hammers mounted on installation vessels that had to hold precise position in open ocean swells. The cable infrastructure required to bring power from 130 kilometers offshore to the onshore grid is itself a significant engineering undertaking. High-voltage direct current cables run along the seabed to converter stations on shore, where the power is converted and fed into the national grid. The cable-laying vessels that installed them worked in sea conditions that routinely suspended operations, adding months to the installation schedule. When all 3 phases are complete, Dogger Bank will have a total installed capacity of 3.6 gigawatts, enough to power 6 million British homes. Phase A began generating power in 2023. Phases B and C are progressing toward completion in the mid-2020s. The total investment across all 3 phases is expected to exceed $9 billion. Every turbine at Dogger Bank sits where there is nothing else. No ground to stand on, no shelter from the weather, no infrastructure that existed before the project created it. In the entire history of construction, very few things have been built in conditions this remote, at this scale, with this little to start from. That is what puts it at number 1. These were some of the world's most remote megaprojects, but they are not the most isolated places on the planet. Moving forward, we will take you to some of these faraway places that are so removed from civilization, they make you wonder if they are real. At -71 degrees Celsius, ink freezes inside pens. Steel becomes brittle enough to shatter. Eyelashes ice over within seconds of stepping outside. And yet, every morning in Oymyakon, around 500 people get up, get dressed in layers of reindeer fur, and go about their day. Oymyakon sits in a valley in Russia's far east, roughly 900 kilometers from the nearest city of Yakutsk, itself already one of the coldest cities on Earth. To get there, you drive 2 days along a highway known as the Road of Bones, named for the prisoners who died building it under Stalin, and whose bodies were buried in the permafrost beneath the road surface. The valley's mountains trap cold air in a bowl, pushing temperatures lower than almost anywhere on the planet. The coldest official reading was -67.7 degrees in 1933. There is a monument in the town square marking the spot where an unofficial reading of -71.2 was recorded in 1924. The monument is outside, in the cold, because of course it is. Daily life here operates on rules that exist nowhere else. Cars are kept running around the clock because if an engine stops in deep winter, it will not start again. Glasses cannot be worn outdoors. The metal freezes to skin within seconds. Phones stop functioning below a certain temperature, which means most of January. The school stays open unless it drops below -52 degrees, at which point even Oymyakon decides it is too cold for children to attend. The ground is permanently frozen. Nothing grows. The diet is almost entirely meat, reindeer, horse, frozen fish, because vegetables cannot be imported in sufficient quantities to matter. What little fresh produce arrives comes at prices most residents cannot afford. There is one shop. There is no plumbing in many homes, which means outhouses in temperatures that make the thought almost incomprehensible. In winter, daylight lasts 3 hours. In summer, it reaches 21 hours, and the temperature occasionally climbs above 30 degrees Celsius, a swing of over 100 degrees across the year that no other permanently inhabited place experiences. Burying the dead is a challenge that requires days. The permafrost must be thawed with hot coals before a grave can be dug. Life in Oymyakon is not surviving despite the cold. It is surviving because of habits built over generations for exactly this. The supply ship comes twice a year, once in July, once in September. Everything the town needs for the next 6 months, food, medicine, building materials, fuel, arrives on those 2 visits. If something runs out in February, it stays out until summer. Ittoqqortoormiit sits on the east coast of Greenland, 500 kilometers north of the Arctic Circle and 831 kilometers from the nearest other settlement on the island. There is no road connecting it to anywhere. For 9 months of the year, sea ice makes boat access impossible. The only way in or out is a helicopter that shuttles passengers to a small airport 38 kilometers away, which itself has just 2 international flights per week, both to Iceland, not to the Greenlandic mainland. To reach the rest of Greenland from Ittoqqortoormiit, you first fly to Iceland, then connect onward. The town's 325 residents live in colorful wooden houses scattered across a rocky shoreline, where polar bears are sighted regularly enough that leaving town without a rifle is genuinely discouraged. The community survives on hunting: seal, muskox, polar bear, walrus, narwhal. The Inuit families here hunt the same way their ancestors did, reading the ice conditions, reading the seasons, reading the animals. The town has a church, a school, a small museum, and a pub that opens 1 night a week. There is one guest house, once described as the most remote hotel on Earth. It has Wi-Fi, electricity, and a stack of 1990s DVDs. Amazon delivers parcels by charter plane approximately once every 2 months. Children grow up here hunting and sledding, then most of them leave for school in Western Greenland or Denmark. Few come back. The school population has dropped from 130 children a decade ago to under 60 today. The people who remain are often those for whom this landscape is simply home, not a hardship to endure, but the only version of home that makes sense. The danger is quieter than extreme cold or violent storms. It is the slow erosion of sea ice. The ice is the highway. It is how hunters travel. It is how supplies reach outlying areas. As it freezes later each year and breaks up earlier, the entire rhythm of life in Ittoqqortoormiit shifts with it. The town has survived a century in one of the most hostile corners of the planet. Climate change may be the first thing it cannot adapt to. Every weekday morning, a mule train loads up at the canyon rim and begins the 8-mile descent into the Grand Canyon. The cargo is groceries. The nearest supermarket is 120 miles away at the top, and there is no road down, so the mules carry it: frozen food, fresh produce, medicine, packages, letters, 5 days a week, every week of the year, in heat that regularly reaches 40 degrees Celsius at the canyon floor. This is the United States Postal Service. This is how it has worked for over a century. Supai is the only place in America where the mail is still delivered by mule. It sits 8 miles below the canyon rim, 300 meters lower in elevation, accessible only on foot, by horse, or by helicopter. The village has around 200 permanent residents, members of the Havasupai tribe, the Havasubaja, the people of the blue-green waters. They have lived here for over 1,000 years. The blue-green water is real. A hidden limestone aquifer above the village feeds a series of turquoise waterfalls that cascade through red canyon walls in colors that seem digitally enhanced until you stand in front of them. The Havasupai built their lives around these waters long before any outsider ever saw them, farming corn, beans, and squash on the fertile canyon floor, hunting in winter, living inside walls of stone that gave them shelter, water, and isolation in equal measure. What the canyon gave as protection, the American government later weaponized as confinement. By the 1880s, settlers, ranchers, and mining operations had been pushing the tribe off the plateau above for years. In 1880, the federal government formalized the displacement, establishing a reservation that restricted the Havasupai to the canyon floor, stripping them of plateau lands they had used seasonally for generations. They spent nearly a century legally fighting to get those lands back. In 1975, the government partially restored them. The tribe's reservation now covers 180,000 acres. Today, thousands of visitors hike down each week to see the waterfalls, entering via a permit lottery held once a year. They pass through Supai to reach the campground. The village has one small lodge, one store, one cafe. No cars, no paved streets, no streetlights. Flash floods are the constant threat. In 2018, a wall of water forced the helicopter evacuation of 200 visitors. In a place with one way in and no road out, a flood does not give warnings. It gives minutes. The mules keep coming regardless. There are no roads across most of it, no towns, no infrastructure, just 1,600 kilometers of high plateau stretching across northern Tibet, averaging 4,800 meters above sea level, where the oxygen in the air is roughly 60% of what it is at sea level, and winter temperatures fall to minus 40 degrees at night. The Changtang is roughly the size of Spain and France combined. Around 500,000 people live there. They move constantly and have for centuries, following their animals across one of the most inhospitable surfaces on Earth. The Changpa, the people of the north, are nomadic pastoralists who have inhabited this plateau for at least 1,000 years. Their economy is yak, sheep, and goat. A family's wealth is measured in animals. In summer, they drive the herds to higher pastures and graze the grasslands before the cold returns. In winter, they move to lower elevations and survive on stored dairy products, slaughtered meat, and butter tea, a mixture of tea, yak butter, and salt that keeps the body warm in a way that nothing else does at this altitude. The tents they live in are woven from yak hair. The yak provides milk, meat, wool, transport, and fuel. On the Changtang, the yak is not an animal, it is civilization. What makes the Changpa remarkable is not merely that they survive here, but that they have constructed a complete and functional life in conditions that would make most of the world's population acutely ill within hours. Altitude sickness, in its severe forms, can kill within days. The Changpa bloodlines carry genetic adaptations that allow their bodies to extract oxygen from thin air in ways that outside visitors cannot replicate regardless of acclimatization. They are, at a biological level, built for a place that was not built for humans. The Chinese government has spent decades attempting to settle the Changpa into permanent villages, viewing nomadism as primitive and inefficient. Many families have been relocated. The ones who remain nomadic are fewer each generation. The grasslands they depend on are being fenced. The herds are shrinking. The knowledge of how to read the plateau, which pasture will hold water in which season, which route avoids the worst winter storms, how many animals a given stretch of grass can sustain without destroying itself, is knowledge that takes a lifetime to acquire and cannot be written down. When the last nomadic families leave the Changtang, that knowledge leaves with them. La Rinconada is the highest permanent human settlement on Earth, sitting at 5,100 meters above sea level in the Peruvian Andes beneath a glacier called Sleeping Beauty. At this altitude, every breath delivers roughly half the oxygen it would at sea level. The nearest city of any size is Juliaca, a 2.5-hour drive down a mountain road that closes for months in winter. Around 50,000 to 70,000 people live here. The city has no running water, no sewage system, and no waste collection. The ground is saturated with mercury used to extract gold from ore and burned off in open shop fronts by miners breathing the vapor directly. That mercury drifts upward, condenses on the glacier above town, and melts back into the only water source available. The rain is acidic with mercury contamination. A local farmer 40 kilometers downstream reported that 83% of his community tested positive for heavy metals in their blood. The mine runs on a system called cachorreo. Miners work 30 consecutive days without pay. On the 31st day, they are allowed to carry out whatever ore they can lift on their shoulders. If it contains gold, they keep it. If it doesn't, the month was free. Miners report being sent deliberately to exhausted tunnels on their payment day. There is no contract, no legal recourse, no alternative. Women are banned from the mines by tradition, so they work the tailings piles outside, sifting discarded rock for fragments the miners missed in cold that drops to -12 at night. La Rinconada is called La Ciudad Sin Ley, the lawless city of Peru. In 2019, 7 miners were found shot in the head inside a single tunnel. Between 100 and 300 bars operate as illegal brothels. An estimated 4,500 women arrived from Peru, Bolivia, and Colombia under false pretenses and could not leave. There is one clinic in the entire city. Life expectancy is 30 to 35 years. The gold extracted here ends up in global supply chains, purchased by international refiners, and has been traced to products made by companies including Apple and Samsung. People come because poverty elsewhere leaves them no better option. Some find gold, most don't. Leaving requires money for the road, and the road takes the money first. Walk around this town on a summer day and the streets are empty. No one is outside. The thermometer reads 50 degrees Celsius. Birds have been found dead mid-flight, fallen from the sky. The tallest tree in town was built from scrap metal because nothing grows here. But underground, it is 23 degrees and perfectly still. Coober Pedy sits in the South Australian outback, 850 kilometers north of Adelaide, about 9 hours by road through nothing. The name comes from the Aboriginal term Coober Pedy, which means white man's hole. It was given that name because from the very beginning, the people who came here disappeared into the ground. In 1915, a 14-year-old boy named Willie Hutchison, accompanying his father on an unsuccessful gold prospecting trip, stumbled across opal on the surface of the dirt. Word spread fast. Miners came from across Australia and eventually from 45 different countries, post-war immigrants, returning soldiers who knew how to live in dugouts from the trenches, fortune seekers who had nothing to lose. They found the opals and they found the heat, and the heat won every time they tried to sleep above ground. The solution was obvious. Go where the miners already were, dig a room, move in. Today, around half of Coober Pedy's 3,500 residents live underground in homes bored into the sandstone hillsides called dugouts. The underground community has expanded over decades to include churches, a hotel, a bookshop, a hair salon, a pool room, and a bar. The Serbian Orthodox Church, carved entirely from rock in the 1990s, has vaulted sandstone ceilings and backlit stained glass that glow amber in the dark. There are no windows anywhere, no wind, no temperature change between morning and night, summer and winter. Residents describe the quiet as absolute. Coober Pedy produces approximately 70% of the world's opals. The landscape above ground looks like the surface of another planet. Crater fields of excavated spoil, rusting machinery, ventilation shafts poking up through the dirt, hole markers warn walkers not to step in unmarked mine shafts. Mad Max Beyond Thunderdome was filmed here. It needed almost no set dressing. The danger is not dramatic. Water is scarce and expensive to pipe in. Medical services are minimal. The nearest hospital with serious capability is hours away. A dugout collapse, rare but not impossible, can happen with no warning. Most residents have simply decided these are acceptable terms for a life that cannot be replicated anywhere else on Earth. The photograph has gone viral multiple times. A lone white house sitting in the middle of nowhere, surrounded by ocean, no other structure in sight, no road, no dock, just open North Atlantic in every direction. The theories that follow every time it resurfaces are spectacular. A billionaire's zombie apocalypse bunker, a reclusive tech mogul's private island, a government secret facility. The reality is considerably more mundane and somehow more interesting. Elodie is one of the Westman Islands off Iceland's south coast, about 8 kilometers from the island of Heimaey, which is the only inhabited island in the archipelago. It is reachable by boat tour from Heimaey, and on a clear day it is visible from the coast. It is remote, but it is not unreachable. What makes it look so isolated is that it has exactly one structure on it, and that structure has a very specific purpose. 300 years ago, 5 families lived on Elodie. They fished, they hunted puffins, the small seabirds that nest by the millions across the Westman Islands. Life was difficult enough that by the 1930s, the last of those families had left and the island became uninhabited. Puffin hunting continued, but as a seasonal activity conducted by visiting groups rather than permanent residents. In 1953, the Elodie Hunting Association built a small lodge on the island to make those hunting trips more comfortable. That is the building in the photograph. It has no electricity, no running water, a wood stove for heat. It is used a handful of times each year when hunters make the crossing to harvest puffins during the nesting season, then locked up and left empty for the rest of the year. The key exists. People have it. Nobody is building an apocalypse shelter inside. The crossing from Heimaey takes roughly 20 minutes by boat in decent conditions. The North Atlantic between the islands can be brutal, and in winter or bad weather, the crossing becomes dangerous enough that the lodge sits untouched for months at a time. Getting stranded on Elodie is not the result of choosing isolation. It is the result of weather deciding otherwise. For those who have stayed overnight in the lodge, the description is consistent. Total silence except for wind and seabirds. No artificial light anywhere on the horizon. A darkness at night that is complete. Most people find it extraordinary. Most are also glad the boat comes back in the morning. There are more polar bears on this island than people. Around 3,000 bears roam the archipelago. The human population is 2,400. Leaving the town limits without a rifle is not a suggestion. It is the law. Longyearbyen sits at 78 degrees north, halfway between mainland Norway and the North Pole, 1,316 kilometers from the pole itself. It exists because of coal. An American businessman named John Longyear arrived in 1906, found coal in the mountains, and built a settlement around extracting it. Workers came, endured the dark and the cold, got paid well, and left. The coal is mostly gone now. The people stayed and kept coming. Today, Longyearbyen has 2,400 residents from 53 countries. Any nationality in the world can move here without a visa, as long as they can support themselves financially. No VAT, lower income tax than mainland Norway. The result is a town that feels like nowhere else on Earth. Thai restaurants, a university, a music festival, a surprisingly serious wine cellar, all surrounded by glaciers and polar bears. 4 months of the year the sun does not rise. For 4 months it does not set. Nobody can be buried here either. The permafrost preserves bodies intact instead of decomposing them, creating disease risk. So the cemetery stopped accepting new residents nearly a century ago. You cannot be born in Longyearbyen. You cannot die there and stay. It is a place you can only pass through, and cut into the mountain just outside town is one of the most important buildings on Earth that almost nobody will ever enter. The Svalbard Global Seed Vault opened in 2008, bored 130 meters into the solid rock of a mountain on the edge of town. Inside, in 3 rooms carved from permafrost, sit over 1.3 million seed varieties from almost every country in the world, duplicates of crops held in gene banks across the globe, deposited here as a backup against whatever comes next: nuclear war, pandemic, climate collapse, a power outage in a poorly funded gene bank in West Africa. The vault covers all of it. The seeds are sealed in foil packages, stored at -18 degrees Celsius, and require no permanent staff to maintain. The mountain itself keeps them cold if the power fails. Properly stored, some varieties will remain viable for over 1,000 years. It has already been used once in earnest. In 2015, the Syrian civil war destroyed the gene bank in Aleppo. Seeds were withdrawn from Svalbard, sent to Morocco and Lebanon, and replanted. The vault worked exactly as designed. There is an irony embedded in all of this. The coal that built Longyearbyen, that gave it its reason to exist, is precisely the kind of fuel driving the climate change now threatening the permafrost the vault depends on. The sea ice that once covered the fjord in winter is gone. The Arctic is warming faster than anywhere else on Earth. The mountain holding humanity's agricultural insurance is in one of the places most visibly losing the battle against the crisis the vault was built to outlast. People come to Longyearbyen planning to stay a year. Most stay 7. There is a phrase locals use, the Arctic bug. For the moment the place gets into you and leaving starts to feel like the wrong direction. The wilderness is immediate. The darkness bonds people in ways difficult to explain to anyone who has not spent 4 months watching the sky stay black at noon. And just outside town, inside a frozen mountain, the world has quietly stored its Plan B. In 1896, a Swiss industrialist named Adolf Geyer-Zeller sketched a plan to build a railway through the Eiger Mountain up to the highest saddle in the Bernese Alps, and then higher still. Everyone agreed it was extraordinary. Most thought it was impossible. It took 16 years. Construction crews, mostly young Italian laborers, drilled and blasted through granite inside the mountain's core, working at altitude in conditions that had no precedent. Several died in explosions, falls, and tunnel accidents. Their names are on a plaque inside the mountain today, almost all of them Italian, almost all of them young. Geyer-Zeller himself died of pneumonia in 1899, 3 years in, having seen just the first section completed. His family finished it. The Jungfraujoch station opened in 1912 at 3,454 meters above sea level, the highest railway station in Europe, a record it still holds today. The journey to reach it from the valley town of Interlaken takes roughly 2 hours. The last stretch entirely underground through the Eiger and Munch, a tunnel bored through the living rock of 2 of Switzerland's most famous mountains. At intermediate stations cut into the cliff face, windows look out over sheer drops and glacier fields. The train emerges at the top into blinding white. 25 years after the station opened, a research observatory was built on a rocky pinnacle 117 meters above it. The Sphinx Observatory sits at 3,571 meters, the highest permanent building in Europe. Getting to it from the train station requires an elevator cut vertically into the rock. Researchers have worked here continuously since 1931, studying glaciology, cosmic rays, atmospheric chemistry, and climate. A team of 2 custodian couples lives on site in rotating shifts, maintaining the infrastructure, sending daily weather reports to Meteo Suisse, and keeping the place functioning through months of winter when temperatures outside drop below -20 and wind turns the exposed platform into something close to uninhabitable. The altitude is the entire reason for being here. Above most of Europe's weather systems, with clear sightlines in every direction and air that has not passed over industrial zones, the Sphinx sees things that lower stations cannot. From its viewing platform on a clear day, you can see into France, into Germany, across the full length of the Aletsch Glacier, 23 kilometers of ice, nearly a kilometer thick, stretching south into the Alps. Most visitors spend 20 minutes on the platform before retreating inside. The researchers stay for weeks. At this altitude, without acclimatization, a brisk walk leaves you short of breath. The cold is not the problem. The thinness of the air is. In the middle of the Pacific Ocean, thousands of kilometers from anywhere, sits an island that shouldn't exist the way it does. No nearby continents, no easy access, and yet it is covered in hundreds of massive stone faces, silently staring out to sea. This is Easter Island, one of the most isolated inhabited places on Earth. The nearest populated land is over 2,000 kilometers away. Flights arrive only a handful of times a week from mainland Chile, and beyond that, there is nothing but open ocean in every direction. But isolation isn't what makes this place extraordinary. It's what humans built here. Scattered across the island are nearly 1,000 moai statues, some standing over 10 meters tall and weighing more than 80 tons. They were carved centuries ago by the island's early Polynesian settlers, using tools far more primitive than what we'd expect for something of this scale. How they were moved remains partially contested. Oral tradition says the moai walked. Experimental archaeology has shown they could be rocked upright on their base and shuffled forward with ropes, requiring around 40 people per statue. The island was densely forested when the first Polynesian settlers arrived, estimated between the 9th and 13th centuries. By the time Dutch explorer Jacob Roggeveen arrived in 1722, it was almost entirely deforested. Trees felled for agriculture, for fuel, and most likely to move the statues. Without forest cover, the soil eroded. Without soil, the crops failed. The civilization that built nearly 1,000 massive stone figures across a 24-kilometer island had consumed the resources that made it possible. Life on Easter Island has never been easy. The island is small, with limited natural resources. Over time, deforestation and overuse pushed the ecosystem to its limits. Some researchers believe this led to societal collapse, turning what was once a thriving culture into a struggle for survival. Today, around 7,000 people live here. There's a small town, an airport, even internet, but isolation still defines daily life. Supplies are expensive, emergencies are complicated, and leaving the island isn't always simple. And yet people stay, because despite everything, there's something almost magnetic about this place. The silence, the scale, the feeling that you're standing at the edge of the world, surrounded by the echoes of a civilization that refused to disappear quietly. Easter Island isn't just remote. It's a reminder that even in the most isolated corners of the planet, humans will always try to leave something behind. If you wanted to disappear from the world in the 1800s, this is where you were sent. In 1815, after his final defeat, Napoleon Bonaparte was exiled to St. Helena, a tiny volcanic island in the middle of the South Atlantic. Not because it was beautiful, but because escape was impossible. The nearest continent is over 1,800 kilometers away. For most of its history, the only way in or out was by ship, a journey that could take days, sometimes weeks, depending on the weather. And for the people who live here today, that isolation is still very real. The island's main settlement, Jamestown, is wedged between steep cliffs with a single road zigzagging up what locals simply call the ladder. There are no highways, no sprawling suburbs, just a tight-knit community of around 4,000 people, where everyone seems to know everyone else. Until recently, if you missed the supply ship, you waited. Food, fuel, medicine. Everything depended on what arrived by sea. Even today, flights are limited and often disrupted by harsh winds, making travel unpredictable. But life here has its own rhythm. There's little traffic, crime is almost non-existent, and time moves slower, intentionally so. People fish, farm, and work in small local businesses. News spreads by conversation more than headlines. Yet, isolation comes with trade-offs. Medical emergencies can still mean urgent evacuation flights. Job opportunities are limited, which pushes many young people to leave, and the cost of imported goods remains high. But for those who stay, St. Helena offers something increasingly rare: distance, from noise, from pressure, from the constant urgency of the modern world. It's the kind of place where history doesn't feel distant, because it never really left. And maybe that's why Napoleon spent his final years here, not just because he couldn't escape, but because on an island like this, the rest of the world feels impossibly far away. If something goes wrong here, help isn't coming anytime soon. In fact, the nearest hospital is over 2,400 kilometers away. Welcome to Tristan da Cunha, officially the most isolated inhabited place on Earth. There's no airport, no quick way out, just a small fishing village called Edinburgh of the Seven Seas, and the endless Atlantic Ocean surrounding it. Fewer than 300 people live here, and almost all of them share just a handful of last names, because the entire population descends from a few original settlers. And life here depends on one thing: the sea. Fishing, especially lobster, is the backbone of the local economy. When the waters are rough, work stops. When supply ships can't dock, essentials run low. Sometimes weeks pass with no contact beyond radio signals. But isolation isn't just about distance, it's about vulnerability. In 1961, the island's volcano erupted. With no way to contain it, the entire population had to be evacuated to the UK. For 2 years, Tristan da Cunha stood empty, a reminder of how fragile life is in a place like this. And yet, almost everyone came back. Today, the island has basic services, a school, a small hospital, even internet, but everything is limited. If you need specialized medical care, you're looking at a week-long boat journey to South Africa, assuming the weather cooperates. Still, people stay, because here, community isn't optional, it's survival. Everyone helps everyone. Doors are rarely locked, and in a world that's constantly moving faster, Tristan da Cunha remains almost unchanged. There are no crowds, almost no noise, and no easy escape. It's just a community of a handful of people choosing to live at the edge of the world. Pitcairn Island is a volcanic rock 3.6 kilometers wide in the middle of the South Pacific, 2,075 kilometers from Easter Island and 5,000 kilometers from New Zealand. It has no airport, no harbor, and no natural landing site. The only way ashore is by longboat through the surf at Bounty Bay. The current population is 35 people. It is the least populated jurisdiction on Earth. Those 35 people are almost all descended from the same 9 men. In 1789, the crew of HMS Bounty mutinied against Captain William Bligh in the South Pacific, set him adrift in an open boat with 18 loyal sailors, and sailed back to Tahiti. Fletcher Christian, who led the mutiny, knew the Royal Navy would come looking. He took 9 of the mutineers, 6 Tahitian men and 12 Tahitian women, and went searching for somewhere remote enough to disappear. He found Pitcairn. The island's position had been incorrectly charted by a British captain in 1767, placing it roughly 330 kilometers from its actual location. That navigational error may be the reason the mutineers were never found. They burned the Bounty in the bay to remove any trace, and the island vanished from the world's knowledge for 18 years. The first decade on Pitcairn was murderous. Disputes over land and women among the mutineers and Tahitian men collapsed into violence. By 1800, every Tahitian man was dead. All but one of the mutineers were dead, and only John Adams remained. 1 man, 9 women, and 19 children. Adams turned to the Bible, raised the children under strict religious order, and by the time an American sealing ship accidentally rediscovered the island in 1808, Pitcairn had become a functioning community of devout Christians. The Royal Navy, when it eventually arrived, granted Adams amnesty. He had already outlived the crime. The islanders today still speak Pitcairn, a Creole language blending 18th century English sailor dialect with Tahitian, incomprehensible to anyone arriving from outside. Most carry surnames from the original mutineers: Christian, Young, Brown, Warren. The island's only church is Seventh-day Adventist. Alcohol is banned. A supply ship arrives every few months carrying everything the island cannot grow or make itself. The island's darkest recent chapter came in 1999, when a British police investigation uncovered decades of systematic child sexual abuse involving a significant portion of the adult male population. In 2004, 6 men were convicted of over 50 offenses. Several served their sentences on the island itself, in a jail built specifically for the trial, watched over by their own neighbors. The island was too small and too remote to send them anywhere else. The population has been declining for decades. Britain has offered free land to attract new settlers. Almost no one comes. The people who remain were born here, or married in, or arrived and found they could not leave in the way they expected. The next supply ship is months away. Antarctica has 3 bars. All of them are at McMurdo. McMurdo Station sits on the southern tip of Ross Island, roughly 3,800 kilometers from Christchurch, New Zealand, the nearest city of any consequence. It is the largest human settlement on the continent, capable of housing up to 1,200 people in summer. dropping to around 150 through the Antarctic winter. Over 100 buildings spread across 2.5 square kilometers of volcanic rock. Dormitories, laboratories, a fire station, a post office, a chapel, a greenhouse, a gym, a climbing wall, a library, 3 radio stations with a vinyl collection, and those 3 bars. By the standards of Antarctica, McMurdo is a city. It was established in 1956 as a U.S. Navy base and functions today as the logistical hub for all American operations on the continent. Almost everything heading deeper into Antarctica, cargo, scientists, fuel, food, passes through McMurdo first. It has its own airport, actually 3 runways, one built on sea ice each year and dismantled before the thaw. The flight from Christchurch takes around 5 hours in a military transport aircraft and lands on a white expanse with no markings visible from the air until the final descent. Most people arriving in Antarctica for the first time land here. Life at McMurdo operates on a rhythm that bears little resemblance to ordinary employment. Work weeks run 54 hours, 6 days. Everyone takes turns cleaning bathrooms. The 2 hours a day of internet access, satellite-dependent, slow, and unreliable, are rationed. During vessel season, when supply ships arrive in January and February, the bars close and alcohol sales stop entirely because the arrival of hundreds of sailors who have spent weeks at sea has historically caused enough disruption that a blanket ban became policy. The people who come to McMurdo are a specific kind of person. Scientists, yes, but also plumbers, cooks, electricians, and welders who signed up to spend months at the bottom of the world maintaining infrastructure in temperatures that drop to -50. Werner Herzog made a documentary here in 2007 called Encounters at the End of the World. He spent most of it marveling at the residents' reasons for being here. Almost none of them straightforward, almost none reducible to career advancement or salary. McMurdo is extreme by any normal standard, but it has bars, internet, a bowling alley that ran for decades before the building was demolished, and a flight home if you need one. The next station on the ice does not. 600 kilometers east of McMurdo's relative civilization, on a floating platform of ice 150 meters thick drifting slowly toward the open ocean, sits something altogether different. Halley 6 Research Station has been operated by the British Antarctic Survey on the Brunt Ice Shelf since 1956. The current version, the 6th iteration, each previous one having been buried, crushed, or threatened by the moving ice, is the world's first fully relocatable polar research station. 8 modules on hydraulic legs mounted on skis. The legs raise as snow accumulates, a meter every year. When the ice beneath threatens to crack away entirely, the whole station can be towed to a safer position by tractor. In 2017, after a crack in the shelf threatened to calve off the section the station sat on and send it drifting into the Weddell Sea, the station was moved 23 kilometers in a single operation. That crack is still growing. Access is possible only during a 3-month summer window. When that window closes, the 16 researchers who remain for winter are cut off until the following season. The sun disappears for 105 consecutive days. Temperatures drop to -56, winds exceed 160 kilometers per hour. A medical emergency during winter means one doctor treating their own patients with no evacuation possible. Not because of policy, but because no aircraft can safely land in those conditions. The station is simply unreachable. The interior was designed with this in mind. A color psychologist was hired to create a palette calibrated specifically to sustain people through months of darkness. The alarm clocks simulate dawn to regulate melatonin. The wood throughout the social module is Lebanese cedar, chosen because it is the only wood that releases a natural scent, and in a place where every sensory connection to the outside world has been severed. The smell of wood matters. The station exists here because in 1985, scientists working at this precise location first detected the hole in the ozone layer. The data that changed global environmental policy came from this shelf, on this drifting ice, at this latitude. That is why Britain maintains a presence here in winter. And that is why, when a crack in the ice forced the question of whether to abandon it, the answer was to build legs and skis and move. The British are roughly 14,000 kilometers from home. They are also roughly 1,500 kilometers from the place we go to next. At the geographic South Pole, the ice sheet is 2,835 meters thick. The station sits on top of it, not on rock. The ice moves roughly 10 meters per year, which means the ceremonial South Pole marker, a mirrored sphere on a striped pole, surrounded by the flags of the original Antarctic Treaty Nations, is repositioned every January 1st to account for the drift. The pole itself is always at 90 degrees south. The station moves. Around 150 people work here in summer. In winter, that number drops to approximately 40. From mid-February to late October, no aircraft can reach them. The jet fuel that powers the only planes capable of making the trip freezes into an unusable gel at -60. The South Pole in winter sits at an average of -49, dropping as low as -82. For more than 8 months, those 40 people are more isolated from other humans than astronauts aboard the International Space Station, which orbits only 400 kilometers above Earth. The nearest other humans, at a Russian coastal station, are 1,300 kilometers away. The winter begins with a tradition. After the last flight of the season lifts off and disappears north, the winter crew sits down and watches all 3 versions of The Thing: the 1951 original, the 1982 Carpenter film, and the 2011 remake, back to back. A story about a small, isolated group in Antarctica being picked off one by one. Everyone finds this funny. Nobody has explained why, but they do it every year. 6 months of darkness follow. The psychological pressure has a name: winter over syndrome, characterized by depression, irritability, memory difficulties, and a condition called long eye, a mild dissociative state in which people stare blankly for extended periods without registering it. Research published after decades of study found that the most significant stressor is not the cold, not the danger, not the physical hardship. It is the monotony and the problem of living in forced proximity to the same small group of people with no relief, no privacy, and no exit until spring. In 1999, a doctor stationed here discovered she had breast cancer. She performed her own biopsy, administered her own chemotherapy, and waited 6 months until a rescue flight could reach her. It was only the 3rd emergency winter evacuation in the station's history. What keeps people coming back, and many do come back year after year, is harder to articulate. The darkness, when it is clear, reveals the Milky Way horizon to horizon with no light pollution. The southern lights appear regularly in the auroral zone. Sunsets at the South Pole last for weeks, the sun spiraling down toward the horizon over the course of a month before finally disappearing. Those who have seen it consistently describe it as one of the most extraordinary things a human being can witness. Then the darkness comes, and the 40 people settle in and they wait. Every place on this list has people. Researchers, miners, nomads, descendants of mutineers, astronauts. Even the most hostile locations on Earth have someone who calls them home, or at least someone passing through. Point Nemo has nobody. It cannot. There is nothing to stand on. Point Nemo is not a place in the conventional sense. It is a coordinate. The single point in the world's oceans that is furthest from any land in any direction. The nearest coastline is 2,688 kilometers away, and the 3 closest landmasses are all uninhabited islands. To reach actual civilization from here, you would travel further than London to New York. No shipping lane passes through it. No flight path crosses it. The ocean here is so far from any coastal runoff, so locked inside a rotating gyre that pushes nutrients away, that it is one of the least biologically active stretches of water on the planet. It is, in the most literal sense, the middle of nowhere. It was first calculated in 1992 by a Croatian-Canadian engineer named Hrvoje Lukatela, who wrote a geospatial program to solve what he called the longest swim problem. If you fell overboard anywhere in the ocean, where would you have to be for the nearest shore to be as far away as possible? The answer was here, and he named it after Jules Verne's Captain Nemo. Nemo means nobody in Latin. When the International Space Station passes overhead, the astronauts aboard are closer to this point than any human being on Earth. The station orbits at 400 kilometers. The nearest inhabited land is more than 6 times further away. The International Space Station itself is scheduled to be guided out of orbit and broken apart over this empty patch of ocean where no ship travels and nothing lives. The ISS is not remote in the way any other place on this list is remote. It is 400 kilometers above the Earth, traveling at 28,000 kilometers per hour, completing a full orbit every 90 minutes. In a single day, the crew sees 16 sunrises. The planet below fills the windows continuously. In one sense, they are never far from home. In another sense, they are completely unreachable. 6 or 7 people live aboard the station at any given time, representing 5 space agencies across 15 nations. They sleep in bags fixed to walls in individual cabins roughly the size of a phone booth. Clothes are worn for 3 days and then discarded. There is no washing machine. Water is extracted from humidity, urine, and condensation by a recycling system that converts everything the crew produces back into drinking water. The food arrives dehydrated or in sealed pouches. Without gravity to settle food into the stomach, eating feels different. Without a shower, washing means wet cloths. Without a floor to stand on, the body naturally adopts a slight fetal curl. Shaving requires a suction device to prevent stubble from floating into equipment. The body responds to all of this badly. Bones lose density at roughly 1% per month without gravity loading. Muscles atrophy without resistance. The spine decompresses, making astronauts temporarily taller. Fluid shifts toward the head, giving many astronauts permanently puffy faces and a sensation of chronic nasal congestion. Vision deteriorates in a significant percentage of long-duration crew members as intracranial pressure changes. The station's radiation environment is a constant background concern, equivalent over a 6-month mission to roughly the dose received from several thousand chest X-rays. None of this is why astronauts find it difficult. What they describe finding difficult is the sameness, the same corridors, the same 7 faces, the same view, however extraordinary. Canadian astronaut David St. Jacques, speaking from orbit, put it plainly, the problem is that everything is a little bit the same every day, and if you are not careful, it can be depressing. Russian psychologists who spent decades monitoring cosmonauts aboard Mir identified a consistent 3-phase pattern: adaptation, then fatigue and low motivation, then hypersensitivity and irritability they called asthenia. Nobody has found a cure other than going home. And yet, the waiting list to go is years long. Because when the ISS passes over a city at dusk, bright enough to see with the naked eye, moving faster than anything else in the sky, the people looking up and the people looking down are seeing the same thing from opposite directions. And the ones looking down say it changes everything. On January 23, 1960, 2 men climbed inside a steel sphere the size of a small room, sealed the hatch, and began to sink. It took 5 hours to reach the bottom. At one point, a loud crack echoed through the hull. The plexiglass viewport had fractured under the pressure. They kept going. When the bathyscaphe Trieste finally settled into the silt of the Challenger Deep, Swiss oceanographer Jacques Piccard and U.S. Navy Lieutenant Don Walsh were 10,916 meters below the surface of the Pacific Ocean. No human being had ever been further from the sky. Then they waited 20 minutes, looked at what they could see through the cracked window, and came back up. Nobody returned for 52 years. The Mariana Trench is a crescent-shaped scar in the western Pacific floor. 2,550 kilometers long and, on average, 69 kilometers wide, formed where the Pacific tectonic plate grinds beneath the smaller Mariana Plate at roughly 2 centimeters per year. At its deepest point, the Challenger Deep, some 300 kilometers southwest of Guam, the ocean floor is 10,935 meters below sea level. If you placed Mount Everest on that floor, its summit would still be more than a kilometer underwater. The water pressure at the bottom is 1,086 times the atmospheric pressure at sea level. roughly equivalent to having 50 jumbo jets stacked on top of a single square meter of surface. Temperature hovers between 1 and 4 degrees Celsius. There is no light. There has never been light. In 2012, filmmaker James Cameron made the descent alone, becoming the first person to solo dive the Challenger Deep. Between 2019 and 2022, a series of expeditions by explorer Victor Vescovo brought the total number of people to have ever reached the bottom to fewer than 30. Fewer people have been to the bottom of the Mariana Trench than have walked on the moon. Life exists here regardless. Sea cucumbers move through the silt. Single-celled organisms have been found at 10.6 kilometers depth. Translucent amphipods, shrimp-like creatures adapted to crushing pressure, were filmed in abundance. Microplastic particles have been found in their bodies. The most remote, most inaccessible, most lightless place on the planet is not beyond the reach of what humans have put into the water. When Pickard and Walsh sat at the bottom in 1960, they reported seeing a flatfish drift past the viewport. Scientists have debated ever since whether vertebrate fish can actually survive at that depth, whether the calcium in their bones would dissolve. No definitive answer has been reached. The trench keeps its secrets. We have barely looked. These were some of the world's most remote places. Next up, we talk about the megaprojects that may not be remote, but are isolated in their own way. Billions were spent to build them, but today they are removed from civilization simply because they have stayed empty over decades. In 2005, Myanmar's military government announced it was moving the capital city, not renovating it, not expanding it, moving it entirely to a patch of scrubland in the middle of the country where nothing existed. They called it Naypyi Taw, and why they built it had a lot to do with the problems plaguing the old capital. Yangon, the old capital, had problems the military government had no interest in solving. It was overcrowded, poorly connected to the rest of the country, and sat close to the coast in a position that military strategists considered strategically vulnerable. A naval blockade or a foreign intervention could, in theory, cut the government off from its own seat of power. Moving the capital inland, deep into the country's geographic center, removed that risk entirely. The military also wanted a capital that projected the image of a modern, powerful state. Yangon's colonial-era infrastructure couldn't be easily retrofitted into that vision. Building from scratch could, so they picked a site, drew up the plans, and started construction before most of Myanmar knew it was happening. What went up was extraordinary by any measure. 20-lane highways wide enough to land a plane on, government ministry complexes the size of small towns, hotels with hundreds of rooms, a stadium, a golf course, an international airport, and enough infrastructure to support a city of millions. The problem is, the millions never came. The highways are empty, not quiet, empty. Photographs of Naypyi Taw's main boulevard look like something from a post-apocalyptic film set, except the buildings are pristine and the roads are freshly paved. There is just nobody on them. The hotels report occupancy rates that wouldn't sustain a roadside motel. The airport handles a fraction of the flights its terminal was designed for. The restaurants have more staff than customers. Senior General Tan Shui ordered the move and gave almost no public explanation. Civil servants were transferred by decree. Government ministries relocated whether their staff wanted to or not. Entire bureaucracies were uprooted from Yangon, a dense, chaotic living city, and dropped into a capital that had been designed from scratch but had never been lived in. Naypyi Taw was master planned to such a degree that none of the growth could emerge naturally. Ministries sit in their own sealed compounds. Residential zones are segregated by government department. Getting anywhere requires a vehicle and a willingness to drive long stretches of road with nothing on either side. Journalists who visited in the early years described a city that communicated power and permanence through its architecture while communicating something closer to absence through everything else. The scale said, capital city. The atmosphere said something had gone wrong. Naypyi Taw remains Myanmar's official capital. The government functions there in the narrow administrative sense. But the vision behind it, a thriving seat of power that would grow into its own ambition, has never materialized. The roads are still empty, the hotels are still quiet. The city built for a future that didn't arrive is still waiting for it. After all is said and done, Naypyidaw may be the emptiest capital city in the world. Naypyidaw was built by a government that ordered its own people to move there. What comes next wasn't built by a government at all. It was built by a private developer who looked at one of the most famous cities in the world, decided to copy it exactly, and placed it in the Chinese countryside 2 hours from Shanghai. On the outskirts of Hangzhou, in Zhejiang province, there is a 108-meter replica of the Eiffel Tower. Around it, Haussmann-style apartment buildings line wide boulevards, ornate fountains anchor public squares, and the architectural language of 19th-century Paris extends across a development that was designed to house 100,000 residents in a corner of eastern China that had no particular relationship to France or anything France represented. Tianducheng was developed in the early 2000s by Zhejiang Guangsha, a private real estate company, during a period when themed residential developments were spreading rapidly across China. The concept tapped into a specific aspiration that was gaining traction among China's emerging middle class: the idea that European aesthetic, European design, and European urbanism signaled a quality of life that standard Chinese residential development couldn't offer. Developers across the country were building Little Venice, Little Austrias, Little Englands. Tianducheng went further than most by committing to an entire Parisian district at genuine scale, with the tower as its centerpiece. The Eiffel Tower replica is not a token gesture. At 108 meters, it stands roughly a third of the height of the original, making it large enough to dominate the surrounding development and visible from considerable distance across the flat Zhejiang landscape. The surrounding streets were designed with genuine attention to the Parisian reference, with building facades, balconies, ironwork details, and street furniture that collectively produced something uncanny in its accuracy. Standing in the central plaza with the tower overhead, the visual experience is disorienting in a way that photographs struggle to fully capture. The development was completed around 2007 and marketed to buyers seeking an aspirational lifestyle at prices that were accessible relative to central Hangzhou. Units sold, the physical city existed, and then, for years, almost nobody moved in. At its emptiest, Tianducheng had a population estimated at around 2,000 people against a design capacity of 100,000. The boulevards that should have been full of residents going about their lives were instead full of wedding photographers. The Eiffel Tower replica and its Parisian surroundings turned out to be extraordinarily popular as a backdrop for wedding and fashion photography, attracting visitors from across the region who came to take pictures and left without staying. The city that was built for residents became, in practice, a photographic destination. The reasons for the emptiness were straightforward. Tianducheng was built far enough from central Hangzhou that commuting to the city for work was genuinely inconvenient. The supporting infrastructure, the shops, schools, restaurants, and services that make a residential area function as a community rather than a collection of apartments, was thin because the population needed to sustain it wasn't there. And the population wasn't there partly because the infrastructure wasn't there. The same loop that trapped other developments on this list played out in a Parisian setting. The population has grown over the years since its emptiest period. Hangzhou's expansion has gradually brought the city's development closer to Tianducheng, improving its connectivity and making it a more practical place to live. Estimates in the early 2020s put the resident population somewhere between 20,000 and 30,000, a significant increase from its ghost town years, but still a fraction of the 100,000 it was designed for. The wedding photographers still come, the tower still stands, and the streets of a Chinese replica of Paris remain quieter than the original by an order of magnitude that no amount of Haussmann-style architecture has been able to close. In 2008, Spain opened a brand new international airport 200 kilometers south of Madrid. It had a runway long enough to handle the largest commercial aircraft in the world, a terminal designed for 10 million passengers a year, and a high-speed rail connection to the capital. By any technical measure, it was a serious, fully functional airport. It handled commercial flights for 3 years. Then it closed entirely. Ciudad Real Central Airport was a product of a specific moment in Spanish history. The early 2000s were a period of extraordinary economic confidence, fueled by a construction boom and cheap credit that made projects like this feel not just viable, but inevitable. Regional governments across Spain were competing to build infrastructure that would signal their economic arrival. A private consortium in Castilla-La Mancha decided that what the region needed was its own international airport, independent of Madrid, capable of drawing both budget carriers and long-haul traffic to a part of Spain that had historically been bypassed by major transport investment. The logic had surface plausibility. Budget airlines were expanding aggressively across Europe. High-speed rail was reshaping how people moved around the continent. Ciudad Real was positioned as a lower-cost alternative to Madrid Barajas for carriers tired of the congestion and fees of a major hub. The high-speed rail link meant passengers from Madrid could reach the airport in under an hour. What the projections didn't adequately account for was why a passenger in Madrid would travel an hour south to catch a flight when Barajas was already on the metro network. Budget carriers tried the route and found that the cost savings of operating from Ciudad Real didn't compensate for the difficulty of convincing passengers to use it. The catchment area around the airport itself, the population within reasonable driving distance, was too thin to sustain meaningful traffic independently of Madrid. The airport needed Madrid's passengers, but couldn't compete with Madrid's airport for them. When the financial crisis hit in 2008, the same year the airport opened, the credit conditions that had made the project possible collapsed. The consortium's finances deteriorated rapidly. Ryanair, which had been the airport's primary carrier, withdrew. Other airlines followed. By 2012, the airport had ceased commercial operations entirely and entered administration. What was left was a perfectly functional airport with nobody using it. The runway sat empty. The terminal, modern and well-equipped, processed no passengers. The high-speed rail station built to connect it to Madrid served no purpose. In 2015, the entire facility was auctioned off for approximately 10,000 euros, a fraction of the 1.1 billion euros it had cost to build just 7 years earlier. There have been intermittent attempts to revive it since. Proposals for cargo operations, logistics hubs, and drone testing facilities have surfaced and largely stalled. The infrastructure is still there, maintained at minimal cost, waiting for a use case that has not yet materialized. The runway that was built for intercontinental jets occasionally hosts light aircraft and the odd promotional event. Ciudad Real Central Airport is not the story of a project that was technically flawed. The engineering worked. The facilities were real. It is the story of a project built on demand that was assumed rather than demonstrated, in a location that made sense on a spreadsheet and nowhere else. Ciudad Real built an airport and waited for airlines that never stayed. What comes next did the same thing, except the airport ended up sharing its runway with wildlife. Sri Lanka's second international airport was built in Hambantota, a small port town on the southern coast of the island, far from Colombo, far from the country's tourist centers, and far from any significant concentration of passengers who might actually need to fly somewhere. It opened in 2013, named after the then-president Mahinda Rajapaksa, whose home district Hambantota happened to be. That detail is relevant to understanding almost everything that followed. The airport was built with Chinese financing as part of a broader infrastructure push in the Hambantota region that also included a deep-water port. The argument was that Hambantota would become a major economic hub, that the port would drive industrial development, and that the airport would serve both the resulting business traffic and tourists drawn to Sri Lanka's southern coast. The government projected millions of passengers within a few years of opening. In its first year of operation, Matala Rajapaksa International Airport handled fewer than 1,000 passengers in total, not per day, in total. Airlines that attempted routes quickly suspended them when the loads made operations financially unsustainable. The terminal, built to international standards with full facilities, processed so little traffic that staff outnumbered travelers on most days. The surrounding region simply didn't generate the passenger demand the projections assumed. Hambantota had no major tourist industry drawing international visitors directly. Colombo's Bandaranaike International Airport, the country's main hub, was functional and well-connected. There was no compelling reason for carriers to operate from Matala when the passengers weren't there, and no compelling reason for passengers to be there when the carriers weren't operating. What filled the silence around the empty terminal was wildlife. Hambantota sits near Yala National Park, one of the highest concentrations of leopards in the world and home to large elephant populations. Animals began moving through the airport grounds. Elephants were spotted on the runway. Bird strikes became a persistent safety concern as the surrounding habitat attracted species that airport operations normally go to considerable lengths to deter. The airport that was meant to connect Sri Lanka to the world became better known for its wildlife encounters than its flight schedule. The financial weight of the broader Hambantota infrastructure project contributed to a debt crisis that eventually forced Sri Lanka to hand operational control of the port to a Chinese state company on a 99-year lease, one of the most cited examples of what critics call debt trap diplomacy in modern infrastructure financing. The airport avoided that specific fate, but remained a symbol of the same dynamic. Large infrastructure built on political ambition and optimistic projections in locations that the underlying economics could never support. Matala Rajapaksa International Airport is still technically open. It handles minimal traffic, mostly charter flights and the occasional domestic service. The terminal is maintained. The runway is usable. The elephants still come. But what happens when you build something for a global event, a moment of national pride, a window of attention that lasts a few weeks and then closes forever? The question is, what gets left behind when it does? Manaus sits in the middle of the Amazon rainforest, 1,500 kilometers from the Brazilian coast, accessible by river or by air, and not much else. It is not a football city in any serious sense. Its local club, Nacional, plays in front of a few thousand people on a good day. The infrastructure connecting it to the rest of Brazil is limited. The climate is relentless, with heat and humidity that make outdoor exertion genuinely punishing for most of the year. Brazil chose it as one of the host cities for the 2014 FIFA World Cup anyway. The decision was partly political and partly about projecting a vision of Brazil as a unified nation where even its most remote regions could participate in a global moment. Manaus had the population to qualify as a host city under FIFA's criteria, and including it sent a message about the reach of Brazilian development. The federal government was in a period of ambitious infrastructure spending, and the World Cup was the vehicle through which dozens of projects across the country were being accelerated and justified. The arena that was built to host those matches cost approximately $270 million. It was constructed in a city with no Tier 1 football club capable of filling it, no realistic prospect of attracting one, and no existing event infrastructure that would give the venue a natural calendar of use once the tournament ended. Workers built it in tropical heat, with materials that had to be flown or shipped into one of the most logistically challenging cities in South America. The roof alone, a striking wave-shaped canopy designed to reference the form of an indigenous basket, required engineering solutions developed specifically for the project. During the World Cup, the arena worked exactly as intended. It hosted 4 group stage matches including England versus Italy, one of the most watched games of the tournament, and delivered the spectacle FIFA and the Brazilian government had promised. The world watched. Manaus was on the screen. Then the tournament ended, and the reality of what had been built became impossible to ignore. A 44,000-seat arena in a city whose football culture couldn't fill a stadium a quarter of that size. The operating costs of maintaining a venue of that scale, the electricity, the staffing, the upkeep of a modern stadium in a tropical climate that accelerates deterioration, ran into millions of dollars annually with no revenue stream capable of covering them. The state government of Amazonas, which inherited responsibility for the arena after the World Cup, has cycled through proposals for alternative uses. It has hosted concerts, local football matches, and corporate events. For a period, part of the facility was converted into a public bus depot, an image that became shorthand internationally for the gap between World Cup promises and World Cup realities. Court sessions have been held there. Universities have used sections of it for classes. None of it adds up to a solution. The arena remains one of the most expensive and least justifiable pieces of sports infrastructure ever built, not because it failed as a construction project, but because the decision to build it in Manaus was made for reasons that had nothing to do with whether Manaus needed it or could sustain it. The Amazon keeps its heat and humidity regardless. The stadium sits in it, maintained at considerable expense, waiting for a purpose that matches its scale. Manaus got a stadium for a tournament that lasted 3 weeks. Athens got an entire complex of venues for a tournament that lasted 16 days. The scale was larger, the ambition was greater, and what was left behind was proportionally more difficult to explain. Greece spent the better part of a decade and somewhere between $9 and $11 billion preparing for the 2004 Summer Olympics. The construction push was frantic, with venues being completed in the final months before the Games opened, and international observers questioning until almost the last moment whether Athens would be ready in time. It was. The Games were widely considered a success. The opening ceremony, held at the main stadium in Athens, was watched by billions of people around the world. What followed was one of the most comprehensively documented cases of post-Olympic decline in the history of the Games. The Athens Olympic Stadium complex, known as OAKA, was the centerpiece of the infrastructure built for 2004. Its main stadium had hosted football for decades before the Olympics, but was extensively renovated for the Games, with a sweeping steel and glass canopy designed by Santiago Calatrava, added to the existing structure at enormous cost. Calatrava's roof became one of the defining images of the Athens Games, a genuinely beautiful piece of engineering that transformed the stadium's profile into something architecturally significant. The broader complex included an aquatic center, a velodrome, a tennis center, a weightlifting hall, and multiple support facilities, all built or renovated to Olympic standard on a site in the northern Athens suburb of Marousi. The investment was justified at the time on the basis that Greece, a country that had never hosted the modern Olympics, despite being their ancient birthplace, owed the Games a facilities package worthy of that history. The International Olympic Committee had returned the Games to Athens after a gap of over a century, and Greek national pride demanded something extraordinary. The problem was that Greece, a country of 11 million people, had built Olympic infrastructure scaled for a global event rather than a national sports culture. The Aquatic Center, designed to host thousands of spectators for swimming and diving events, had no major swimming club or federation capable of programming it consistently after the Games. The velodrome had no professional cycling circuit to anchor it. The tennis center hosted a professional tournament for several years before that too faded. The main stadium continued to host football for Athens' major clubs, but the broader complex around it deteriorated steadily. When the Greek financial crisis hit after 2008, the maintenance budgets that might have slowed that deterioration disappeared almost entirely. Photographs of the Athens Olympic complex taken in the years following the crisis showed venues with cracked tiles, overgrown vegetation pushing through concrete, faded signage, and facilities that had been world-class a decade earlier sitting in visible disrepair. The Calatrava canopy, once a symbol of Greek ambition, hung over a stadium that struggled to fill even for major matches. The Greek government has repeatedly announced plans to redevelop the broader Olympic site, with proposals ranging from commercial development to expanded sporting use. Progress has been slow, constrained by the same financial pressures that allowed the decline to happen in the first place. Some facilities have seen partial renovation and renewed use. The decay that characterized the post-crisis years has been partially arrested, but the gap between what was built and what Greece could realistically sustain was visible almost from the moment the closing ceremony ended. The Games left Athens with infrastructure designed for a moment that lasted 16 days and a maintenance bill that lasted decades. Athens built for a global moment and couldn't sustain what it left behind. What comes next is different. It wasn't built for an event. It was built for a future that the economics promised and then failed to deliver, street by street, apartment block by apartment block. In the mid-2000s, a developer named Francisco Hernando, known in Spain as Paco el Pochero, began building a city from scratch on a plateau south of Madrid. Not a neighborhood, not a development, a city designed to house 30,000 families across more than 13,000 apartments, with schools, shops, and the full infrastructure of a functioning urban community. It was called El Quiñón, part of the broader municipality of Cesena, and it was going to be one of the largest residential developments in Spanish history. Hernando had made his fortune in construction during Spain's long property boom, and had watched land values and housing demand climb year after year through the 1990s and into the 2000s. The logic of El Quiñón was straightforward from his perspective. Madrid was expensive. Commuter demand was strong. A large-scale development offering affordable housing within commuting distance of the capital would sell. Spain's banks were offering mortgages freely. Buyers were borrowing freely. The market seemed to guarantee that whatever got built would find someone to live in it. Construction moved quickly. Thousands of apartments went up across the plateau, block after block of residential towers rising from ground that had been empty scrubland. Infrastructure was installed, roads were laid, and the physical shape of a new city emerged from the landscape south of Madrid at a pace that reflected the confidence of the boom years. Then 2008 arrived. The Spanish property market collapsed with a speed and totality that wiped out the assumptions the entire project had been built on. Mortgages dried up overnight. Buyers who had reserved apartments walked away from deposits rather than complete purchases they could no longer finance. The banks that had been funding construction pulled back. Hernando's finances, stretched across an enormous project still mid-build, came under severe pressure. What was left was a development that was partially complete, partially occupied, and profoundly unfinished in ways that made the occupied sections feel as desolate as the empty ones. Families who had moved in found themselves living in finished apartments surrounded by vacant blocks, with shops that never opened because the customer base never materialized, and schools operating at fractions of their intended capacity. The community infrastructure that makes a residential development feel like a place to live rather than a place to sleep had never had the population to sustain it. Cesena became one of the most photographed symbols of Spain's housing crisis, a physical manifestation of what happens when construction outpaces demand by years and the market correction arrives before the city can establish itself. Journalists and documentarians visited repeatedly through the 2000s and 10s, capturing images of empty playgrounds, shuttered commercial units, and half-finished towers standing alongside occupied ones. The population has grown slowly over the years since. Some of the empty units have eventually sold as prices fell to levels the market could absorb. The development is no longer as stark as it was at its emptiest, but it never became the city it was designed to be, and the plateau south of Madrid still holds the outline of an ambition that the Spanish economy built and then withdrew from before anyone could move in. Cesena was a city built for people who never arrived. What comes next is bigger, newer, and somehow even emptier. The ambition scaled up. The result stayed the same. Forest City was supposed to be the future, not a housing development, not a suburb, but an entire new city built on 4 artificial islands off the southern tip of Malaysia, just across the strait from Singapore. The developer, Country Garden, one of China's largest property companies, unveiled plans in 2016 for a self-contained urban environment housing 700,000 people, complete with its own schools, hospitals, shopping districts, offices, and a design language that promised something between a tropical resort and a modern metropolis. The target market was Chinese buyers, not Malaysians, Chinese nationals looking to park wealth overseas, secure a second residence, or position themselves for eventual emigration. Country Garden marketed Forest City aggressively in mainland China, opening sales offices across dozens of cities and presenting the project as a gateway to Southeast Asia with the stability of Malaysian property law and the proximity of Singapore's economy. Sales in the early years were strong enough to suggest the model was working. Then Beijing moved. In 2017, China tightened capital controls, restricting the ability of its citizens to move money overseas for property purchases. The flow of Chinese buyers that Forest City had been built around slowed dramatically almost overnight. The sales offices in mainland China went quiet. The reservations that had looked like momentum evaporated as buyers found themselves unable to complete purchases or unwilling to navigate the new restrictions. Malaysian politics added another layer. In 2018, then Prime Minister Mahathir Mohamad publicly criticized Forest City, raising concerns about foreign ownership of Malaysian land and questioning whether a development explicitly marketed to Chinese nationals served Malaysian interests. His comments landed during an election campaign and carried weight that went beyond rhetoric. The project became politically charged in a way that made Malaysian buyers hesitant and further dampened the international appetite that had already weakened. What got built in the years that followed was real in the physical sense. Towers rose from the artificial islands, roads were laid, a shopping mall opened, along with hotels and some residential units. The islands themselves, reclaimed from the sea at considerable environmental cost to nearby fishing communities and coastal ecosystems, were transformed from water into land and then into the skeleton of a city. But the skeleton never filled in. Occupancy rates across the completed residential towers sat in single digits for extended periods. The shopping mall that opened to serve a community of hundreds of thousands operated for a fraction of that population. Roads built for urban traffic carried almost none. The design that had looked futuristic in the marketing materials looked eerie in reality. Wide boulevards and modern architecture in a place where almost nobody lived. Country Garden has continued to develop sections of the project and has attempted to reposition Forest City away from its original Chinese buyer focus toward a broader international market and Malaysian residents. A special economic zone designation was announced, with proposals for tax incentives and visa arrangements designed to attract businesses and residents. Some of those initiatives have shown early signs of interest. Whether any of it will close the gap between the city that was marketed and the city that exists is a question Forest City is still in the middle of answering. The islands are there, the towers are there, the infrastructure is there, the 700,000 people are not. Forest City was built for a market that politics shut down before it could arrive. And next, we have a technology city, built from scratch in the middle of the African savanna that aimed to be Kenya's Silicon Valley. In 2008, the Kenyan government unveiled a plan to build a world-class technology city from the ground up on 5,000 acres of semi-arid savanna land 60 kilometers southeast of Nairobi. It would house universities, research institutions, tech companies, and a permanent population of up to 200,000 people. It would generate hundreds of thousands of jobs, attract foreign investment, and transform Kenya into a regional hub for innovation and digital industry. They called it Konza Technopolis, and they called it Silicon Savannah. The vision was not entirely without foundation. Kenya had genuine strengths to build on. Nairobi was already East Africa's most significant business hub, with a growing technology sector, a relatively young and educated population, and a mobile payments industry that had produced M-Pesa, one of the most successful financial technology products in the developing world. The idea that Kenya could position itself as a technology leader on the continent was reasonable. The question was whether building an entirely new city from scratch in the savannah was the right way to do it. Construction began in earnest around 2013. The Kenyan government invested heavily in the initial infrastructure, laying roads, installing utilities, and building the physical foundation that would attract the private investment and institutional tenants the project depended on. International consultants were brought in. Partnerships with foreign universities and technology companies were announced. The project attracted significant attention from development finance institutions and foreign governments interested in Kenya's growth story. What followed was a decade of slow progress, repeated deadline revisions, and a persistent gap between announcement and reality. Phase 1 of the project, which was supposed to deliver a functioning initial district with anchor tenants and resident population by the mid-2000s, stretched well beyond its original timeline. Companies that expressed interest in locating there found that the supporting ecosystem, the housing, the retail, the schools, the density of other businesses that makes a technology cluster function wasn't yet in place. And without those companies moving in, the supporting ecosystem had no reason to develop. The project was caught in a loop where each component waited for the others to arrive first. The Kenyan government has maintained consistent public commitment to Konza throughout, with successive administrations reaffirming it as a national priority and continuing to invest in its infrastructure. The Kenya ICT Authority, which manages the project, has announced new partnerships and milestones at regular intervals. Some physical progress is visible. Roads exist, buildings have gone up, a data center has been established on site, but as of the mid-2020s, Konza remains largely empty savanna with infrastructure at its edges. The technology city that was supposed to be generating economic activity by the 2000s is still in its early stages, still waiting for the critical mass of residents and businesses that would make it self-sustaining. The deadline has moved so many times that it has become less a target than a horizon, always visible and never quite reached. Konza is not a failure in the way that a collapsed airport or an abandoned stadium is a failure. The project is alive, funded, and still being built. But 15 years after its announcement, the Silicon Savannah remains more savanna than silicon, and the gap between the ambition of 2008 and the reality of today is wide enough to raise serious questions about whether the model of building a technology city from scratch in a field and waiting for innovation to follow was ever going to work the way its architects imagined. Konza is still waiting for its future to arrive. What comes next didn't wait for anything. It was built fast, built extravagantly, and sank before anyone could move in. Dubai has a habit of building things that shouldn't exist. The Palm Jumeirah, an artificial peninsula in the shape of a palm tree, visible from space. The Burj Khalifa, the tallest building ever constructed. And in the early 2000s, a project that made both of those look restrained by comparison. 300 islands, arranged in the shape of a world map, built from scratch in the open waters of the Persian Gulf, 4 kilometers off the Dubai coastline. The World Islands were announced by Sheikh Mohammed bin Rashid Al Maktoum in 2003 and developed by Nakheel, the same state-linked developer behind the Palm projects. The concept was straightforward in the way that only Dubai's ambitions managed to be straightforward. Dredge sand from the Gulf seabed, deposit it in precisely arranged formations, and sell the resulting islands to private buyers who would develop them into ultra-luxury residences, hotels, and resorts. Each island represented a country or region of the world. Buyers would effectively own their own private nation in miniature, 4 kilometers from one of the wealthiest cities on Earth. The dredging operation required to build 300 islands across 6 square kilometers of open water was one of the largest marine construction projects ever attempted. Hundreds of millions of cubic meters of sand were extracted from the Gulf seabed and deposited with a precision that had to account for tidal movement, wave action, and the settling behavior of dredged material over time. The islands were surrounded by a breakwater constructed from rock imported specifically for the purpose, designed to protect the formations from the wave erosion that would otherwise gradually dissolve them back into the Gulf. By 2008, the physical islands existed. They were sold. Buyers from around the world paid prices that reflected Dubai's peak property market confidence, with individual islands changing hands for tens of millions of dollars. Development plans were announced for hotels, private villas, and resort complexes that would make the world one of the most exclusive addresses on the planet. Then, the global financial crisis hit, and Dubai's property market collapsed with a totality that exposed how much of the Emirates' development boom had been built on debt and assumption rather than underlying demand. Nakheel, which had borrowed enormously to finance its projects, required a state bailout. Development financing for the world dried up almost overnight. Buyers who had purchased islands found themselves holding title to sandbanks with no infrastructure, no fresh water, no electricity, and no realistic prospect of development in the near term. For years afterward, the world existed as it sounds, a collection of sand islands in the Gulf, shaped like a map of the planet, accessible only by boat, with almost nothing built on them. One island, named Lebanon, saw some development activity. A resort called the Heart of Europe has been under intermittent development on a cluster of European islands for years, with some sections eventually opening to visitors. But the vast majority of the world's 300 islands remain undeveloped, sitting in the Gulf sun, slowly eroding at their edges despite the breakwater, waiting for a development boom that has never returned at the scale the original vision required. The islands are real. The world map, viewed from the air, is clearly visible. What was supposed to fill it never came. Dubai built its islands and watched the market walk away. What comes next didn't lose its buyers to a financial crisis. It never really had them to begin with. In the forested hills of Mudurnu, a small town in northwestern Turkey, roughly 200 kilometers from Istanbul, there are 732 identical French chateaux. They sit in neat rows across the hillsides, each one a miniature castle complete with turrets, pointed roofs, and the visual language of European aristocratic architecture, transplanted wholesale into the Turkish countryside. From a distance, it looks like a film set. Up close, it looks like something stranger. Every chateau is empty. Most have never been lived in. The windows are dark, the interiors unfinished, and the streets between them silent. The project was developed by Serot Group, a Turkish real estate company, and construction began around 2014. The target market was wealthy buyers from Gulf states, particularly Saudi Arabia and Kuwait, who had shown appetite for luxury second homes in Turkey during a period when Turkish real estate was attracting significant foreign investment. The chateau aesthetic was a deliberate choice, designed to signal European luxury to buyers for whom that aesthetic carried aspirational weight. Each unit was priced at between $400,000 and $500,000, with the full development representing a total investment of approximately $200 million. The timing looked reasonable when construction started. Turkey was growing, foreign buyers were active in its property market, and the Gulf states had the wealth and the appetite for exactly the kind of product Serot was building. The company sold a significant number of units off-plan, with buyers putting down deposits on chateaux that existed only in renderings and scale models. Then, the conditions that made the project viable collapsed in sequence. Turkey's currency entered a period of severe volatility, with the lira losing a substantial portion of its value against the dollar and the euro over a relatively short period. For foreign buyers who had priced their investment in stable currencies, the instability introduced risk that hadn't been part of the original calculation. Diplomatic tensions between Turkey and Saudi Arabia during the same period cooled Gulf appetite for Turkish assets specifically. Serot ran into financial difficulties that slowed and eventually halted construction before the development could be completed. What was left was 732 shell chateaux on a Turkish hillside in various states of completion, with no residents, no functioning infrastructure, and a developer in financial distress trying to restructure its debts and revive sales in a market that had moved on. The company filed for bankruptcy protection and spent years attempting to find a path back to completion, with periodic announcements of renewed sales activity and restructured financing that have not yet translated into a finished, occupied development. The images of Burj Al Babas became widely circulated online precisely because they produce a specific visual dissonance that is difficult to look away from. Hundreds of identical castles, architecturally detailed and physically complete in their exteriors, standing empty in a landscape that has no particular relationship to anything they reference. The Turkish hills don't need French chateaux. The chateaux don't have anyone living in them. The whole thing sits on the hillside, generating no revenue, serving no purpose, and looking exactly like what it is, an idea that made sense in a spreadsheet and nowhere else. Burj Al Babas ran out of money before it could find its residents. What comes next ran out of everything, at a scale that made Burj Al Babas look like a minor miscalculation. This is what happens when the largest property developer in the world builds a fantasy park in the middle of its own financial collapse. China. Evergrande Group was, for a period in the 2000s, the largest real estate developer in the world by sales volume. It built across hundreds of Chinese cities, sold millions of apartments, and accumulated a land bank and a debt load that were both extraordinary in scale. At its peak, Evergrande employed around 200,000 people directly and supported the livelihoods of millions more across its supply chains. It was not just a company, it was a significant component of the Chinese economy. It was also, as it turned out, built on a financial structure that required continuous growth to remain functional. The moment that growth slowed, the entire architecture began to crack. Evergrande Fairyland was one of the more visible symptoms of that crack. Located in Langfang, a city between Beijing and Tianjin in Hebei province, it was conceived as a massive theme park and resort complex, part of Evergrande's strategy to diversify beyond residential property into tourism and entertainment. The site covered an enormous area, with construction beginning in the mid-2000s on what was projected to become one of the largest theme parks in China, rivaling international destinations and drawing visitors from across the country. The scale of what was partially built before construction stopped is visible in the abandoned structures that remain on the site. Enormous themed pavilions, ride infrastructure, decorative facades, and the skeletal frameworks of attractions that were never completed stand across a development zone that has been frozen mid-construction for years. The visual effect is of a fairyland in the most literal sense, a place that exists in a state between imagination and reality, where the shapes of things are present, but the things themselves are not. Evergrande's financial crisis became public in 2021 when the company missed payments on its debt obligations, triggering a collapse in confidence that spread rapidly through its operations. The company had accumulated liabilities of over $300 billion, making it one of the most indebted companies in the history of global capitalism. Construction sites across China were halted as suppliers and contractors stopped receiving payment. Hundreds of thousands of Chinese homebuyers who had paid deposits on unbuilt apartments found themselves in legal and financial limbo, their money spent, their homes unbuilt, and their developer unable to fulfill its obligations. Fairyland was one casualty among thousands of stalled Evergrande projects, but it became one of the most photographed because the gap between what it was supposed to be and what it became was so visually immediate. A theme park is supposed to be the most deliberately joyful kind of construction, empty, unfinished, and silent. It communicates the opposite of everything it was designed to produce. Evergrande entered a formal restructuring process, and Chinese courts have been managing the unwinding of its obligations for years. Some of its residential projects have been taken over by state-backed developers and completed. Fairyland has seen no such resolution. The site remains largely as the collapse left it, a monument to the moment when the mathematics of endless growth finally stopped working. Evergrande built a fairyland and ran out of money before the lights came on. What comes next was built for millions of shoppers in a country with one of the fastest growing consumer economies on Earth, and still managed to become one of the most desolate places a person can walk through. The South China Mall in Dongguan was designed to be the largest shopping mall in the world. When it opened in 2005, it was exactly that: 5 million square feet of retail space, divided into themed zones modeled after international destinations, an Arc de Triomphe replica at the entrance, a Venice-style canal running through one section, an Egyptian pyramid, a replica of the St. Mark's Campanile. The developers didn't build a mall. They built a city inside a building and waited for China's rising middle class to fill it. 2 decades later, they are still waiting. For most of the 2 decades since it opened, the South China Mall has operated at occupancy rates below 5%, not 5% below target, 5% total. Out of thousands of retail units across 5 million square feet, only a handful of tenants ever moved in. The canal sits without gondolas. The Arc de Triomphe stands at the entrance to corridors that echo because nothing absorbs the sound. Security guards patrol zones where no shop has ever opened. Dongguan was a manufacturing city, not a consumer one. The workers who filled its factories sent money home rather than spending it locally. The middle class the mall was designed to serve lived in Guangzhou and Shenzhen, cities with their own retail options and no particular reason to travel to Dongguan for a shopping experience they could find closer to home. The fundamental demand that the entire project was built around didn't exist in the location it was built for. The developers, the founders group, had watched China's economy expanding at a pace that made almost any bet on consumer growth look reasonable in the early 2000s. They chose Dongguan partly for its land costs and partly on the assumption that a destination large enough and spectacular enough would generate its own gravity, pulling visitors from across the Pearl River Delta region. That assumption turned out to be wrong in a way that no amount of replicated European architecture could fix. Walking through the South China Mall in its empty years was an experience that journalists and photographers documented extensively, precisely because it produced a specific kind of unease. The scale communicates abundance and possibility. The silence communicates failure. Ceilings designed to feel grand feel oppressive when there's nobody beneath them. Corridors that should be navigated through crowds become long, quiet tunnels with flickering lights and the occasional security guard moving through on a route that never changes. There have been partial revivals. In recent years, sections of the mall have been converted to entertainment and dining uses, with some success in attracting local visitors on weekends. Occupancy has crept upward from its lowest points. The developers have repeatedly announced renovation plans and rebranding efforts, some of which have partially materialized. The mall is no longer quite the ghost town it was at its most empty, but it has never come close to the vision it was built for. The themed zones still sit largely vacant. The canal still runs through a corridor that sees a fraction of the footfall it was designed for. The largest mall in the world, built at the peak of confidence in China's consumer future, remains a monument to the gap between what an economy looks like on a growth chart and what it actually needs on the ground. What closes this list has been standing for over 30 years without ever being finished. In one of the most isolated and controlled countries on Earth, it is not abandoned, it has never been completed, and it may never be either. In 1987, North Korea began construction on a hotel in its capital, Pyongyang, that was intended to be the tallest building in the world. The Ryugyong Hotel rises 330 meters in a pyramidal form of 105 floors, its 3 wings tapering to a point that dominates the Pyongyang skyline from almost every angle in the city. When it was designed, it would have been not just the tallest hotel on Earth, but one of the most architecturally striking buildings anywhere in the world. A statement, in concrete and glass, that North Korea belonged in the same conversation as the most ambitious nations on the planet. Construction stopped in 1992. The building has never been occupied. 37 years after the first foundations were poured, the Ryugyong Hotel remains unfinished, a shell of concrete standing over a city that has built its entire visual identity around projecting strength and permanence. The reasons construction stopped in 1992 are not officially acknowledged by the North Korean government, but the timing aligns precisely with the collapse of the Soviet Union, which had been a primary source of economic support for Pyongyang. The loss of Soviet aid triggered a severe economic contraction in North Korea that deepened through the 1990s into a famine that killed hundreds of thousands of people. In that context, completing a luxury hotel was not a priority that could be sustained. For years, North Korea's response to the unfinished tower was to pretend it didn't exist. Maps of Pyongyang omitted it. State media never referenced it. Foreign visitors reported being discouraged from photographing it, which was a difficult instruction to enforce, given that the building is visible from most of the city. An unfinished 330-meter concrete pyramid is not easily edited out of a skyline. Construction resumed in 2008, funded in part by an Egyptian telecommunications company that had entered into a business arrangement with the North Korean government. The exterior was clad in glass panels that gave the building a more finished appearance from a distance, and cranes appeared on the upper floors, suggesting interior work was underway. Then, activity slowed again. The cranes eventually disappeared. The building's status returned to the ambiguity that has characterized it for most of its existence. As of the mid-2020s, the Ryugyong Hotel has never hosted a guest, never opened a restaurant, never operated an elevator carrying a paying visitor to one of its upper floors. It stands in Pyongyang as it has stood for decades, present and impossible to ignore. Its glass exterior reflecting the sky over a city that officially considers it a symbol of national ambition and practically treats it as something closer to an embarrassment. No other building on Earth has been under construction for this long without ever being used. No other government has maintained the fiction of a functioning skyscraper while leaving it empty for a generation. The Ryugyong Hotel is not just the emptiest building on this list. It is one of the strangest objects in the modern world, a monument to ambition so frozen in place that it has become its own kind of permanence. It was supposed to open in 1989. It is still waiting. Whether built in the world's most remote places, left behind in empty landscapes, or standing alone against the elements, these megaprojects exist on the edge of human ambition. Some redefined what's possible, and others became monuments to miscalculation. But which of these megaprojects did you enjoy the most? Would you like to visit any of these far-off places? Let us know in the comments below. Like this video and subscribe to Signum for more interesting stories from the world of mega construction.